C'è? Ale? Ce l'hai? Vai. Questo forse è spento.
Test. Test.
Sì, scusate, va giusto che non ti
Dai,
strisci nella barba.
forza.
Perché sennò...
Se no devo sentire il pelo.
Sì.
Test. Va bene?
Sì.
Ok,
Ce
bene.
l'hai Ale? Alza un po'.
Test. Bene.
to start?
Ready.
Just a few seconds more.
Bene.
Okay, I believe we can start. So, hello everybody, welcome to Sala Gnocchi, and welcome to our first speaker of the day, Duarte Carmo.
All right.
No,
Please.
As he likes to say, Duarte works in the intersection of machine learning, data, software engineer, and people. Today, he will talk about how to improve a RAG workflow, demystifying some ideas, and giving us some practical advices. At the end of the talk, I remember you that we are going to have a Q&A session, and please use Slido to send your questions to the speaker. So thank you, Duarte, and the stage is yours.
Wow. Well, good morning, everyone. I'm excited to be here. Thanks a lot, PyCon Italy, for organizing this incredible conference. So today I'm going to talk about RAG, tricks from the trenches. It's about practical lessons from building retrieval systems in Python. Now, before I get to the juicy part, I have to do the mandatory introductory slide. Ciao tutti, sono Duarte. I'm Duarte. I'm originally from Portugal, but I'm based in Copenhagen, Denmark. I'm a machine learning /software/AI engineering contractor with over 7 years of experience. In the past, I worked in things like strategy, product management, management consulting, Big Four, things like that. Now I mainly help companies solve hard problems with machine learning and software. And in the future, there's a long-running joke about Italians in this conference, but I'm completely in love with a city called Ancona, which is a couple of hours down here, 2 hours down with the Frecciarossa in the Le Marche region. So I'm still convincing my wife in eventually living there. She's not convinced yet, but I'm working on it very, very hard, I promise you. I also have a blog and a newsletter. You might like it down on my website below. You might enjoy it, you might not, but I have fun writing it a lot. So if you're keen, join it. Cool. Let's get to the serious stuff. Before we get to the serious stuff, there's a long-running theme of me being a big fan of Italy. I am. This is my third PyCon Italy. There's two common themes here, alcoholic beverages and pizza. I have to say that I'm a big fan of both, but I'm also a big fan of the Adriatic coast. So if you have the opportunity to get lost towards the south here, towards the side of Croatia and the Adriatic coast, I really advise you to do so because it's one of the best places in the world, and that's where I spend at least a couple of months a year every year. So I definitely advise you to go there. All right, now we can go to the serious stuff. So today, we'll talk about RAG. My goal is to give you like simple, but yet practical advice of stuff you should do. I don't want to get too theoretical. I don't want to get too over the top. I just want to give you simple and practical advice. We'll talk about a couple of things. We'll talk about what's RAG, why your embedding choice sucks, why structured outputs matter. We'll talk about exploiting contexts and summaries. We'll talk about your beautifully ugly production data. We'll talk about, in fact, if your system is actually any good. And then I'll give you some final thoughts and resources for going beyond. Cool. What's RAG? I'm sure you heard about it on LinkedIn. Here's me running Olama locally, asking Quen 30B, where is PyCon Italia this year? Asking it to no think, because I don't want to wait 15 minutes for it to do its long thinking process. And it tells me as of now, PyCon Italia is typically held in Rome, but the exact venue and date can vary each year. Well, I mean, I'm not sure Rome is the right place. I actually been to Florence in the last ones, and now we're in Bologna, so Rome might not be exactly the correct answer. So RAG is all about this. RAG is all about providing the right context to your large language model. That's all it is. And this is a tweet from Hamo Hussein, a person I really like in the community, which is really, really true. It's just about providing the relevant information to your LLM. Now, you might also seen this implementation of RAG, which is I take an external document, chunk it up into paragraphs, embed them all and put it on a vector database, take my query, embed that, do a top K of the most similar embeddings to the response, and then I put that in an LLM and call that the response synthesis. That's RAG. Now, one of the things that annoy me about this graph, even though I'm a big fan of Sebastian Rachka and his book, Machine Learning Q and AI, is the fact that RAG doesn't mean vector DB at all. In fact, we can use one of my all-time favorite libraries of Python called sentence transformers. I can take a model, dump it on the MPS device on my Mac, take a corpus of text, and then just query the corpus, embed the queries, and just use util.semantic search, and bam. The most similar to deploying Python with containers is how I deploy Python apps with Docker. Score is 0.85. So no vector databases. If someone tries to shove a vector database onto your company, making sure that you have to use a vector database from the 25 different vector database companies out there, rest assured, you do not. I could just pickle file this into my local machine and try to embed it like that. That's the way to go. Now, we see that RAG doesn't really mean vector databases, but in fact, RAG has become extremely simple. For example, there's another library I'm a big fan of called LanceDB. And with LanceDB, I can get a full-fledged working RAG system in about 25 lines of code. I take my model, then I define this Lance model, which allows me to define the text, which is the source field that will be embedded. It allows me to define the vector, which is the vector field. If the table doesn't exist, I create the table, open that table. The query is where was I born? And then I just do a table.search, allows me to do the whole embedding dance really quickly. And then I have my prompt, you're a helpful assistant. Here's the text, the context, here's the question. Here's my RAG system in 25 lines of code. Now, it has become really simple. But the premise of this talk is, has it actually become that simple? Because really, like, why did you choose those embeddings? Are users actually ever going to trust your responses? What if the user asks for a summary of your 10 gigabyte table? Is your production data really that clean with all of these nice questions and like full stops and punctuation and whatnot? Because when I Google, for example, it's dirty. It's really dirty. Like, I just write the minimum words possible. And how do we know our system is actually any good? We have no clue if we just do a 25-line RAG system. That's it. You're just putting something into oblivion. OK, let's get started. First of all, your embedding choice sucks. Big time. This comes from a trauma of people telling me that embeddings don't matter. Let's consider a super simple example. OK? Let's just look at a sentence. The user query is, can weight affect asthma? It's a pretty simple question. Now, my corpus of documents is a set of 32,000 texts. They have an ID. These are the texts or the chunks or the paragraphs. And these are the title of the scientific paper from which they were extracted. 32,000 passages. Now, let's say I just build an initial RAG system. I take the user query. In the corpus, I put my 32,000 texts, get my model, sentence transformer, do the whole dance, top K, give me the top 10. That's it. I retrieve the most similar 10. But now for each one of these results, I'll check, is the answer, is the context actually relevant? I ask an LLM, hey, is this piece of paragraph actually relevant to the question? And we score about a 16.54, which effectively means that almost 75% of every chunk you give to the context is effectively useless. And now let's change just a single line of Python code. The only thing that changed in this slide is the name of my model. Instead of using all mini, I'm using NVIDIA NV embed v1. And now my score is 62.89%. That's about a 300% increase in your retrieval score. All I needed to change is a single line in Python code. And so, I mean, that's pretty nice. Like, it's pretty low-hanging fruit. It's just a single line. Oh, it's done. Work done. I have an incredible system. But of course, devil's in the details, right? But this exercise that I'm talking about is actually the main focus of something called MTEB. So what you just looked at, these 32,000 passages, are from a data set called the Cure v1 data set, which is open on Hugging Face. This work is from a project called MTB, Massive Text Embedding Benchmark. And that's all they do. They compare embeddings in terms of different languages, Italian, English, Polish. They look at different domains, like the medical domain, the code domain. They look at different tasks, like retrieval, clustering. And their goal is just to compare all of these embedding models throughout all of these different tasks to tell you which one is best for you to use. And the best thing is most of this is all open source. And so here you see like the old model that we're using and the new model that I just changed a line of code and my 300% increase on performance. Of course, again, nothing comes for free, right? Embeddings are really important. So for me, it's almost like, why wouldn't you take this free kind of performance boost? But on another side, of course, the embedding model that I mentioned has like 4 times the size or more than 10 times the size of the original one. So there's infrastructure involved. There's latency involved. There's a couple of things that you need to take into consideration. Now, if you don't care about any of those, then just change your single line of code and you'll do great. Cool. Let's talk about structured outputs. So structured outputs is a door that I've been banging on for a while. For me, structured outputs is really what brings sanity to large language model-enabled applications. So to give you an example, I take a user info base model, a Pydantic base model. I do this thing called, I basically create my client, and I do an API call to GPT 3.5 Turbo. God, this slide is old. And then I do the response model user info. And I tell it, John Doe is 30 years old. And then I can do, on the response, it actually gives me back a Pydantic model. So I can say userinfo.name, and it will give me John Doe. And I can do userinfo.age, and it gives me the age. This is, for me, what finally brings sanity to the large language model apps. This is the way that we can integrate our large language model applications with the rest of the world. In fact, this is MCP. The Model Context Protocol is using this tool calling mechanism under the hood. For me, MCP is nothing more than 34 Pydantic-based models in a single file hosted in a fast API. That's it, because effectively, that is what it is. It's just using this tool calling mechanism that models nowadays are trained to do and give you back this nice little response. And for me, it's great. I really like it. Cool. But why do we need this? Because users, including me, hopefully you as well, we have trust issues with large language models. And a great thing to deal with this, and a great way to solve this, is to make verification easy. What do I mean by this? Let's create a fact-based model. My fact-based model has a fact, which is a string, and has a substring quote. My question answer is also a base model that has the question, a string, and it has a list of facts. Now, a fact is that effectively something that is mentioned by the large language model, but needs to exist on the original context. So I'm enforcing that whatever fact the large language model tells me needs to be a substring that exists in the text. If this sounds weird, this effectively is what it does. If I ask it, what does Duarte do? And I give it a context. My name is Duarte. I'm a Portuguese technologist, whatever, yada, yada. And I ask a question. It will give me 2 answers using this kind of structured outputs. The first answer is, Duarte is a Portuguese technologist living in Copenhagen. But I know for a fact now that that substring, it comes directly from the context. So this is a way of us avoiding that the large language model kind of hallucinates. It's a way of us verifying that whatever the large language model said is effectively in the context. Of course, it doesn't solve the problem of hallucinations and things like that, but at least gives us a little bit more confidence, and most of all, our users more confidence, than whatever the large language model is saying exists, in fact, in the context. And users love this, effectively. It makes their life really easy because they stop mistrusting everything that is happening. And now, structured outputs are nice for answer verification and for bringing sanity to large language model-based apps, but all questions are not the same, right? Like some questions that the user asks will require API calls. Others will require different prompts, different escalations. Some of them will require human in the loop, and someone asks some weird thing, and we want a human to come in. And structured outputs also provide to us a way of dealing with these things. So let's say we have some user input, and then we don't know if it's going to be to a vector database, to a text-to-SQL system, or to a REST API call, or we have some sort of other user input that, depending on what they say, If they start insulting my application, I might send them somewhere or somewhere else. If we can effectively use this same base model strategy to define a question and a query type. And now a query type is an enum that effectively tells us where to route our query towards. So if the user's question, so effectively we take the user's question, we send them to a small LLM that is capable of structured outputs, and then depending on what they say, we can route that answer accordingly to where we want. It's especially nice if you use something really small and capable, because hey, we don't need to solve AGI for query routing. It's a pretty simple task, right? And this is a nice graph from a nice book I read called the LLM Engineer's Playbook. I advise that book, it's really nice. Cool. Now let's talk a little bit about exploiting context and summaries. Now, there was a little bit of a weird thing on Twitter where someone took a database of tweets or blue sky skeets, and everyone was really mad because it was a bunch of user data. So I made an exercise, and I took a database of not 1 million, but 2 million blue sky skeets, which are the equivalent for tweets. And now I'm using polars to basically just give me the data set from Hugging Face. I really love this polars kind of feature. We just like give me the Hugging Face data set. And I collect those 2 million tweets. Now, let's say we have 2 questions we want to ask about this data set. My first question is, the user asks, what are the main trends in these 2 million blue sky tweets? The other question is, what are people saying about Bologna? Now, these questions are a little bit different, and we should effectively probably treat them in a different way. Like, if someone asks me about Bologna, then I go here to my keyword filter. Like, you're being very specific. It's like, how's the weather in Lisbon? Or why are people leaving blue sky? We want to give the LLM the specific context about Bologna of what is happening. And so RAG is great for this, right? Like a keyword search would be great for this. I want to focus on the things that are very specific for the LLM. Now, if I ask something like, summarize this data set, what are the main trends? Then we want to give the LLM like a general feel of what's going on in our data set. We don't want to match something specific. We want to give it like an idea of what my data set is. And the question is like, how the hell do we do this? Because we can't just shove our 2 million database tweets in the context of an LLM, even though those are getting really big. And so the first thing that we can do is just detect if it's like a representative filter question or a keyword filtered question. And this is the alternative of not using structured outputs. This is a very disgusting prompt with some examples of telling me, hey, if someone asks summarize the data, that's representative. If someone asks me about like, describe the negative, neutral, and positive perception of physicians, then I want something keyword-based. It's just a way of routing, which is much worse than using structured outputs. This is like me telling you why you should use structured outputs. Now, effectively, if the user asks me, give me a summary of the data set, and we do the traditional kind of RAG workflow, we'll effectively match all of the red sentences that are about summaries of data sets, because that's what you will match. And we don't want that, right? We don't want to get into the context of tweets about summaries of data sets, right? What we want is when a user asks me, give me a summary of the data set, we effectively ask, we want a little bit of each one of these different topic clusters. We want to get a little bit from there, a little bit from there, and a little bit from there. Now, who can guess what is the nice thing that gives me a little bit from everywhere? A little bit from everywhere is something that I've put on almost every slide. It's a library that I've put in almost every slide that I've presented. And we all go back eventually to scikit, which is one of my favorite libraries of all time. And we effectively just use for this k-means. We take our k-means class. We have our embeddings. We can fit k-means. We can say, hey, I want like 5 clusters. And then for each of these 5 different clusters, we'll take some items from each of these clusters. And what will result is that the context that I'm giving the LLM now is much more like, here's the feel of the data set. Of course, there's many ways to improve this. This is not perfect by any means. But it gives that nice kind of, here's a little bit of the data set, which in my case kind of solved my bottom a couple of times. Cool. Now we talked a little bit about exploiting context and summaries. let's talk about your beautifully ugly production data, which is one of my favorites. Because when we're preparing like our RAG systems, right, we're all excited. We're like, yeah, example questions from users. Is treatment of class 2 malocclusion recommended during childhood? Or what is the predictability of upper molar distalization with clear aligners? Like, it's very like beautiful questions, really well formulated. When then we go to production, what happens effectively is instead of is treatment of class 2 malocclusion recommended during childhood, people say treatment malocclusion childhood okay? Or what is the predictability? Distalization predictable upper molar? Like, this is how I Google. I don't know about you guys, but I try to write the minimum number of words to the thing, understand what I'm saying. It's like, I'm not going to write like question marks and things like that. And I do the same thing for all these LLMs. And then so this is effectively, we're going into the field of query understanding, which is the process of understanding what the user exactly means. And LLMs are also great at this. So I can use effectively an LLM to take the original search, PyCon Italy location 2025. That's a little bit more how I would Google for something. What effectively the LLM can do is take that single query, transform that into 5 different queries that are a little bit more understandable. And then for each one of these queries, we conduct like a top case search. And then we effectively can combine all of these results and then select the ones that we care about the most. So it's a way of kind of diffusing and decrypting whatever the user question was, and then match that context. Now, the way you select then these combinations is totally up to you. There's re-rankers, there's vibes, there's just send to LLM, select them for me. There's a couple of ways of doing it. And so we can use LLMs to not only derive the metadata from the query, we can look at their query and create a plan of queries from a single query. We can pre-process the query, and we can also use it to re-rank things, which is a really nice way. So we can use these LLMs to kind of as a pre-processing engine for our questions. Now to the core part. Is your system actually any good? And I was coming to PyCon Italy from Portugal, actually. And I got on a plane someone called Rodrigo. He's also presenting. He's a really popular guy in the community. And he asked me, okay, we were talking about what we do and what I do and what he does. And he's like, oh, Duarte, cool, but like, how do you get clients? And I told him, the best way to get clients is to have clients. And he looked at me like, that doesn't mean anything. But it's true because, in fact, this also applies here. Like, the best way to evaluate your system is to get users. And this sounds horrible for a programmer. And we love this, right? We love using this RAG evaluation framework, like here's data set, context precision, faithfulness, answer relevancy. We love seeing these numbers go up, right? Like number go up, even though we have no clue what the number really means. It's like, yeah, like our context precision is 0.8, cool. So how I normally do how I tackle things is I would say like, I start with BM25. I don't even go embeddings route. I say like, here's my corpus of texts. Here's keyword search called embedding 25. It's pretty fast and it's mostly okay. And I just say, here's my like retriever. Fun fact, I had a production system just like this for about 8 months in production, and everyone thought I was using like advanced like embedding search. I was using BM25. And when we compared BM25 with embedding search, guess what? BM25 was always better because it was incredibly keyword searchy and all the users were just like writing Googles like me. So it was great. And it was pretty much free. First tip, start simple. Second step, log everything. Here's Loguru. I log the query, I log the context, I log the precision, I log the responses, I log everything. And so now I have something in place. Now I'm logging something. It's time to improve it. I can see what's going on. I can look at my data. I can analyze different examples. Are they any good? And now we start getting into, is the context relevant? Now we start thinking about precision. But you don't start thinking about precision before you put something out there. And I did a very weak attempt at the framework of like how to think about this, which is use your model or prompts to generate inferences or your retrieval system to generate inferences. Then you monitor and collect them. Then you extract the interesting cases where you failed tremendously. You review your data set and optimize the model or the RAG system. You create a new version of your service. You collect and you restart all over again. And you go into this flywheel. You just look at what's going wrong, increment, make it better, and go all over again. And I'm not talking about context and precision. I'm telling you about looking at your data and realizing where you failed. Cool. Final thoughts and resources. I got 1 minute left. It's just search. We start and it's just search. We talk about re-ranking, fine-tuned embeddings, faithfulness, relevancy, multi-hop querying. But in the end of the day, for me, it's just good search. It's just about giving your large language model what it needs, when it needs it, and using all the tools you can at your disposal. No need to get super complicated. Some concepts. Closing the loop early and starting really, really simple. Getting something out there. Log the most important metrics and decisions. Be close to production. I feel like people are scared of production. Don't be scared to understand what's going on in production. Note down your issues and improve them, and then repeat. Here's some resources for you. If you're interested in this topic, I put them all in a tiny URL. If you're interested, you need to photo them. I think RAG resources, tiny URL. And that's it. Thank you very much, guys.
So, thank you very much for your talk. We have some questions on Slido from the audience. So, first, what about facts that are not easily validated by your documents? So, for instance, there are questions implying complex reasoning by the RAG system. Is it possible to include reasoning in RAG systems?
Is it possible to include reasoning in your RAG system? It is. I actually do it quite often. What I actually do lots of times is that when I have something like this, question answer, I will very often do, my base model will be question, answer, and reasoning. And then the LLM will give me the question, like the answers, and will also give me the reasoning of why it reached this question. Even better, the reasoning here, instead of a string, can be a list of strings. So you can say, give me your steps for reasoning to answer this specific question. Yeah, it's a little bit of a hack. Like some people say that like structured outputs kind of affect the quality of LLM outputs, but I don't care because they work really well.
So, do you run automated tests on the bad examples you find in prod? How do you keep the tests up to date when your prompt and system changes?
Yeah, it's also a good question. Great question. So I brought this sad excuse for a framework. I was talking with my friend Luca yesterday about this. There's kind of two types of tests that I see, right? There's things that I want to have in CI that never fail or like fail to a certain percentage. Those are kind of the golden things, the golden behavior items. And those ones I keep in CI. But when I'm iterating on my system, I like to have this kind of notion of like a golden data set, like a data set of the default behaviors I like my system to have. And those are the ones that I will add on with the edge cases that I will kind of test on my notebooks and ensuring they are good. So I don't really like putting my golden data set of me experimenting in CI. For me, it's more like an iterative, where are things failing, where can I improve them type of thing. I don't know if I answered the question directly, but yeah, those are some sentences about it.
Okay. Now a suggestion. What is, in your opinion, the best framework or project to start building RAG systems?
None. No, effectively, like, of course, some of these lang graphs and lang chains are really good for you to get a prototype out there. But eventually, like, you will need to know what's going on. And so I don't start with the code, first of all. I start with like how I see the system. And then, of course, you can jump to these frameworks, but a lot of these frameworks will be doing some like Kung Fu Ninja on your prompts that you don't really know what's going on. So I'm a big advocate of also like getting your hands dirty and knowing what's going on. And so don't start with the framework. Like if you're starting with, if your question is what is the framework, you're starting the solution with the technology. And for me, you start the solution with the solution, and then the technology comes along and is whatever is best for you. But I don't recommend frameworks.
Sure. And first, you showed up on the slides some Pydantic.
Yeah.
And somebody asked about, have you ever messed with Pydantic AI?
I have. It's a great framework, but I don't use Pydantic AI. I think it's a great framework, but I've tested it a couple of times. It's nice, integrates well with Pydantic. I really like plain Pydantic because, as like I showed you, it's nice that we have like the base models, but you can also like do all types of like methods on these models to like validate SQL for text to SQL or do a lot of crazy things. So like default Pydantic is really nice as well.
Okay. So thank you very much. For other questions, you can reach him.
Thank you very much. Thank you guys.
still need 3 minutes for the online people. Plenty of time. Do you have something funny to tell us before you talk?
I can say a lot of jokes, but in Italian. I haven't prepared that.
Start the microphone. Just it?
So I just say hello.
Okay.
Welcome, everyone.
Just a few minutes that we are waiting for the online people to join us. You ready?
Yeah, sure.
Okay, I believe we can start.
Yeah.
So welcome everybody to Sala Gnocchi, and welcome Michele to the stage.
Thank you for having me. Thank you.
Michele is technical director of the R&D unit at Zucchetti, and today he is going to talk you about how to efficiently run advanced AI models on CPU, making them resource-friendly and cost-effective. I remember you that at the end of the talk we are going to have a Q&A session, and remember to use Slido to send your question by there. Michele?
Thank you. So, hello, everyone. Thank you for being here. Today we will discuss this nice topic, efficient AI with Python, and specifically we will try to understand how and why running this using CPUs. So let's start with something mandatory about myself and about my current role, just to give you also a bit of context. I like to define myself a passionate software engineer, and actually I have had the opportunity in my career to work with a lot of different programming languages, technologies, and so on. All of these have brought me to my current role that is serving as technical director of a research and development AI unit called Madness Lab. More of this in a while. Basically, we are delivering and designing, deploying AI-enabled solutions using Python, Angular, Java, but also working on a cool DevOpsSec pipeline, and obviously with scalable cloud deployment, of course. So what is the Madness Lab? Madness Lab is this R&D team. Actually, we are made up with, we are 7 people, but we are growing, and we want to. We think we have enabled a collaborative and non-hierarchical structure that it's a really good place where we love to work. And also, we work on very interesting topics. Some of them you can see listed here. It's interesting, given the previous talk, that I've noticed that we do a lot of things that sucks in our RAG system, but it's the way, it's why we come here. And also, we come here to show up our business path, how we are trying to bring together 2 sides of our work. On one side, we have the business needs, the business side, where we have to develop, we have to deploy products, we have to bring value to customers and also to management. And on the other side, research and development things, the funny thing, where you have the opportunity to discover, to test, and to try a lot of funny stuff around AI and computers. So why this talk? this will be the road, the things that I will try to tell you. Why this talk? Because we think that for the AI to fill up the last mile, for the AI to reach the end user and end products, it needs some requirements. We need to understand when we develop our solutions that we need to fulfill some requirements. The limit as now for us, for our experience, for our work, in the AI, it's not the technology. AI can do a lot of interesting and cool things. The limit is how AI can bring real value to every work day life of the end user. So, what are these requirements? I will focus on these three things that are things that get up in every requirements survey, in every customer talk, and very, very often when we speak about a new product, a new feature. They are privacy, reliability, and efficiency. I think speaking about private AI, the discussion could not be more actual. We have the AI Act, we have the GDPR for a long time, but also I think we have a real concern from the end user for where their data will be flowed through, who will see and why will see and how will see their data, if they will be stored, if they could be used, analyzed, and so on. And very often the response to these concerns from the customer side, from the company owners, it's no one. No one should see my data, no one should analyze it, and so on. So privacy, it's absolutely a first requirement. And on the other, very side to side with privacy comes efficiency. So if we need to bring software that speak directly with the user, or in any manner comes to end user, it should be efficiency. We could not rely on great integrator, great providers that have a lot of resources, a lot of GPUs, a lot of server farm. But we need something that can be efficient both on the fast side, so it needs to provide fast solution, fast reply, fast answers, fast outputs, but also that could be cost efficient. So in order to save time and money, that is very often a business needs. The last thing is reliability, last but not least, because as also in the previous talk we have heard of, customer and company owners need to trust AI, need to trust solution generated with AI, and so here comes the reliability. We need to give the user the ability to take what we bring them and use them, trust them, get value from them, okay? This is the problem, these are the requirements we will try to fulfill, and there come the approach. So we have mainly two kind of processor. We have more, but mainly we base our research on CPU and GPU. GPU obviously remain the preferred choice, and probably in the future, until quantum computers come in 20 years to substitute them, will be the preferred choice for creating new powerful model, to also fine-tuning them to have better models that give us nice and very, very good things. But on the inference side, when we have our model, when we have chosen what to use in our application, we could rely a lot on CPU. Why? Inference is very different from model training. Inference, it's possible and it's used on CPU. And also there are a lot of software solutions that will come up in the future that will further narrow the gap between CPU and GPU on inference. So we envision that in the future, CPU will be, I think, more and more. When we move to CPU, here comes the framework, OpenVINO. There are a lot of framework out there. As I said, there are a lot of work on CPU inference. We have chosen at this time OpenVINO because it's a toolkit that is open source. It's provided by Intel, not the last one. And that it's very, very reliable, and it's very simple to manage your existing models, export them to the OpenVINO format, and use them in production on CPU hardware. Obviously, it comes with a Python runtime API, but also it brings a model server, so you can, like Llama server and so on, so you can use directly their server to serve the models. Okay, so we have the technology, the hardware technology. We need models. About the models, we have to do two things. We could not, we could try to run great models with many billions of parameters on CPU, but probably it will be slower, and it will be a time waste. What we need to do is to consider small models. Small models are very, very powerful and flexible. True, in the base model, in the base flavor, they have a very, very low accuracy. If you compare Qwen 0.5, 1.5 billion models with Gemini, ChatGPT, or whatever, obviously it's useless. But if you use model tuning, so if you have a curated dataset of your data, if you take your business case, your business needs, and create a dataset that you could use to fine-tune an existing model, these models gain a lot of accuracy that are what you need in your use case, and also while maintaining a good efficiency, and they remain very fast. That is also something that you want to maintain. The last side of preparing and choosing your model is quantization. I will not go deeply in technical details about how to do fine-tuning, how to do model quantization, also because I have seen very interesting talks in this conference. But the point is, basically, the model have a precision that is very extreme, but again, if you have a specific case, a specific business case, you want to adapt a custom model to your task, you don't have to have you don't need to have that extreme precision. You can export, quantize your model, maintaining faster inference speed, maintaining scalability, because model size, it's also about scalability. It's also about another thing that we'll see in a while, that it's first token response type. First token response time, when you deal with end user, when you deal with a system like a virtual assistant or something that give answers to users, the first token response time is your metric. It's your main metric. So we have chosen models. We have chosen our base models. There is no low-hanging fruit. There is no a silver bullet. Every model has their task. So you will try. We have based a lot of our research around Qwen, but there are a lot of models out there that are specific and that are better for different tasks. So you will have to fine-tune them, evaluate the results, test them in production. I will take for sure one thing from the previous talk. You need to bring this to the end user. You you can't rely on metrics, on evaluation metrics, confusion metrics, whatever. You need to bring this to the end user and see how this performs. In the business, this is the key. I totally agree. Okay, we have the models. Now we finally come to the code. So, taking time. This is a simplified version of our real production code. I split up the logging stuff, the metric stuff, and so on, just to show you how you can simply, with OpenVino framework, load the model that you have trained, that you have prepared for your business logic, use it, and then stream also. This is a streaming version of this method. And so you can simply load your model. You will use transformers and torch as you will with any other kind of models. So OpenVino bring you classes that will work on top of this. You will load the tokenizer. You will apply the chat template, so take the user inputs in terms of your system prompt and the user messages that you are trying to get a response for, and you will tokenize them. Here I use a class to get the streaming on, and then I simply generate the model response. With temperature, the sample, and maximum tokens value, and so on. It's as simple as you see. Again, it's real. It's really like any other model that you will use on GPU. You can use OpenVino also to do inference on GPU. It supports both sides. What we do, OpenVino? OpenVino will take your model and will take it through two steps. A first step where OpenVino will export in a format that is optimized, that is better for CPU inference. And the second step is that the first time you run your model on your production architecture, it will further improve the model to get a better inference on your specific processor you are using. So if you run this on an Intel Sapphire 4 or on another kind of Intel processor, it will do two different performance improvement, and this is cool. They are going better on this. Okay, going back to the slide. There is a lot of things about this. As I said, we have created all the business pipeline from business case to real production software. And in this, we have took a lot of things from the community. The model we use are open sourced. The OpenVino framework is open source, and also so we are trying to bring back something to the community. We have a Docker Hub profile where we leave the Python Docker image that we use for our software. They are also have a better efficiency in terms of using CPU inference. So if you would, you can check it out. We also have a lot of repository in GitHub, like Helm chart, like a Docker system that we use to develop locally and to spread our development. And so, what results do we have? Let's try it. This is deployed on Google Cloud on a standard machine N3, I think, something like that. As you can see, the throughput is good. So you can use this for end-user application. Also, I've tried with strictly prompt. Reply with a concise and precise answer. because I don't have so time. And the thing you have to see here that it is, again, scalable. It's deployed on simple infrastructure, so you can have cost optimization. You can save a lot in terms of resources and system requirements. You can go on-premise. You can ask your clients to bring you a physical server, and you don't need any specific requirements. You just need to know what the clients will bring you. You will optimize the models and then serve things directly on the client's architecture. And again, the first token response time is your main metrics, because if you create a virtual assistant or something similar, you can compare the response and the performance of your solution with a solution that uses Gemini, ChatGPT, Mistral, or whatever. If you you don't have two latency in the first token response time. If the user has to 0 to no, very low latency on the first token response, it will not pay attention if you are using local models or good models. Again, you need reliability, but you have trained your model. You have a model that is very custom, that is very specific to your business needs, and that are very powerful to your task. Last thing, I have 2 minutes ago, again. So I think, as we all know, it depends. So testing for us work better. We do data extraction, we do text embedding, we do virtual assistants, so with a powerful RAG where you give the context to your model and give answer to the user. And the thing that we have used really depends on our task. We think that we can compete with great integrator, with great solutions that are out there if we bring custom things to the user, if we develop our custom models that are very performant, that are very reliable, and that give real value to the user. The final thing that all we try to do is to give real value to the user, so that when they open our application, test our workflow, they will start using it. The problem that we notice with with a survey with our customers is that very often when they open an AI-powered solution, they will come back very easily to the path that they know. We don't want that they come back. We want that we give them something that can be loved, can be used, and can empower everyday work life. So this is where we are now. There is also a lot of things that we would like to improve. The path is very long. So if you want to get in touch with us, want to send us a mail, it will be interesting. Thank you.
Thank you very much, Michele. We have some questions from the audience. So, what do you usually use these models for? Can you provide some examples where lower accuracy is acceptable?
Yep, sure. The topics that I showed at the start in this slide, basically it's something that we really do. So we have really developed solutions that are in production about these topics. We think that in very specific case, again, like vision models, if you have to detect specific things, so you can create your custom model. your custom vision model that works very well and very fast with your use case. The same in a RAG system. We don't do generic RAG system. We do generic RAG system where we enrich the text with contextual retrieval, with various kind of re-ranking about the results that we'll do as context, that will provide as context to the model, so the model can do a small work.
Okay. What should be, a practical question, what should be the minimum requirement CPU in terms of computational powers to run this kind of models?
We tested, the thing is, what's your requirement on the latency? If you have requirements of low latency because you are going in production to the end user, probably you have to go for a M3 Intel Sapphire 4th generation CPU. But if you want to test, if you want to give something locally that perhaps can work in batch mode, so something with a queue where you have all the time to process things, we have run the OpenVino on a Raspberry Pi 3 on an i3 processor of 7th generation. So it really works. Not everywhere, but also the thing is the time you have for your outputs to come us out.
Sure. And just regarding latency, somebody asked if you ever tested the latency performance against, of course, GPUs, but also against other CPUs deployment without using OpenVino, for example.
Yep, we have CPUs. ZPUs are faster, so GPU are faster. This is something we have to deal with. But about different kind of framework that can do inference on CPU, we choose OpenVino also for its stability, for its support, business support. That it's something that it's not secondary if you are bringing something to the user. So there are other frameworks where we had maybe comparable results, but you have to choose on more sides, not only latency.
Okay, so we still have many curiosities for you. What is the largest model you have deployed on CPU with similar performance as GPU? Just a curiosity.
Probably we have experimented a lot with multimodal models like Qwen vision model, and we have deployed the 14 billion Qwen for the 14 quantized, fine-tuned, and so on. But it has a comparable performance like the one that you will deploy on a GPU, on a A100, and so on.
Oh, wow.
So, but it is created, optimized, and has this kind of performance because we have narrowed the task that he can complete.
Okay. So another curiosity about the requirements, the hardware requirements. You were talking just about CPU's requirements, but what about RAM? So regarding the fine-tuned quantized model you showed us, how much RAM is required to run that inference?
It depends on the size of the models, but for 8 gigabyte of RAM is sufficient for small models like Qwen 0.5, 1.5 billion. So if the model increases in size, you need also more RAM. But for the 14 billion models, if I remember well, we use 32 gigabyte of RAM. So something affordable.
So something we can have also on our laptops.
Yeah, sure.
Okay.
All these things of experiment and research, we start from running it on our laptops. for the purpose that if they run locally, if we have a good, not latency, but good performance and good reliability local, when we go to the cloud, we have a scalability, we have performance improvement because the cloud has a different architecture and different processor, but this would mean that in the cloud will be really, really better. But first, all of these things starts from testing it on our laptops.
Okay. And another practical question before the code. So somebody asked how you practically create an OpenVINO optimized model, and if you can share how you explicitly put inside the code how to import the library and select the use of CPU.
Yep, sure. Not in an answer, but I think we have two things. We have also a space on Hugging Face where you can find a lot of OpenVINO already exported models everywhere on Hugging Face, on GitHub, also on the OpenVINO website. There is a filter that you can use when you search for models on Hugging Face. You can search directly for models that support OpenVINO format. Some models are not, were not on Hugging Face. We have created our Hugging Face space where, for example, we have the model that maybe I have screenshotted, the Quen 2 7 billion. It's one of our tests that we have exported. There are really simple notebooks. You can export it using Colab or using an Hugging Face space, as we have done.
Wonderful.
We don't have the notebooks added to the repository, but if you go to the Madness Lab space on Hugging Face, we can provide next week for also for the notebooks.
Okay, so thank you very much, Michele.
Thank you, everyone.
1, 2, 3. No, it doesn't work. No, it's as far as. Okay, does it work? I mean, it does, but it seems to be very quiet. Yeah, 1, 2, 3. Yeah. Okay. Ну, я тебя опущу потом. Ага. Ага. Ну да, да, вот так. Окей. No. Ну я так упрусь, как и надо не забыть это, таймер поменять. А ты сказала?
So, hello everybody, welcome to Sala Gnocchi, and thank you to Irina and Oleg to be our speaker at this moment.
Yeah, thank you. I hope you can hear me well. Today
Yes.
we are going to try to answer the question whether the prompt engineering is. Oh, sorry, you wanted to say something.
So sorry. Irina and Oleg are data scientists and co-founders of Dataforce Solutions. That is a company specialized in delivering end-to-end data science and AI services. Today, they are talking about how can prompts be automatically learned from data. And I remember you that at the end of the session, we are going to have a Q&A session. So please remember to use Slido to send your question to the speakers. So thank you very much.
Yes, thanks again. As I already said, today we are going to try to answer the question whether the prompt engineering is dead. Before we begin, you can scan this QR code to follow the slides on your screen. This probably would be a good idea because the screen is positioned rather low and some of the content might be obscured by me. Okay, so let's start with a bit of motivation. Why do we even care about prompt engineering? I guess it was really, really difficult not to notice that in the last couple of years, LLMs were a rather big deal. For example, just looking at the NeuroIPS 2024 poster presentations grouped by topics, we can see that LLMs take up a substantial portion. However, obviously, LLMs are not only popular amongst researchers, and we get more and more exciting tools like LangChain, Cursor, Copilot, etc. And even large enterprises are stepping in with their LLM-powered offerings. You probably know or used Apple Intelligence, which provides native AI capabilities to iPhones and Macs. However, when we look at how those systems are working under the hood, we see something like this. Very long manually crafted prompts with directives like, please do not hallucinate, please output your answer in a certain way, etc., etc. The overall idea is that complex systems require complex prompts, and crafting those prompts manually is far from being trivial. They need to be precise, non-ambiguous, and well-structured. Therefore, we can raise a natural question. Can prompts be automatically optimized given some training data? And basically, the answer is yes. And now I will hand it over to Irina, who will explain how this can be done in practice.
Thank you. Before we proceed further, we need to make a distinction between simple or single component and compound or multi-component systems. In single component systems, we typically deal with just one prompt. Think of a summarizer or a translator. There is one input, one output, and the prompt is pretty straightforward. Tuning that prompt manually is actually a manageable task. You write the initial prompt, test it, tweak a word or two, and can already see satisfactory results. In contrast to simple systems, compound systems are made up of multiple components chained together in a pipeline. As an arbitrary example, imagine a retrieval augmented QA system. Here, our program first retrieves some documents, generates an answer that is grounded with these extracted text passages, summarizes, and then rewrites the text. Such multi-component systems are becoming increasingly more popular, and there are a few key reasons for that. First of all, they often outperform monolithic models, especially when designed thoughtfully. In addition, because each module is isolated, you can inspect each step independently. Also, you know that different tasks don't always require the same horsepower. With compound systems, you can use different LLMs for different tasks. For example, a smaller and cheaper model for extraction, while a more capable one for reasoning tasks. That lets us optimize cost-performance trade-offs more intelligently. Finally, such systems give you more ways to ground the model's output with external tools or some specific trusted data sources. But here's the catch. This added structure comes at a cost. We're no longer dealing with just one model or one prompt. Instead, we have a chain or graph of components, each with its own role and, more importantly, its own prompt. These prompts are no longer independent. For example, a change in the first component might alter the output a bit. That would result in a huge and unintended side effects in the later steps of a pipeline. Because of these cross-prompt dependencies, manual prompt optimization becomes infeasible. So while compound systems offer important benefits, they also introduce serious challenges in terms of prompt optimization. We already established earlier that there must be a way to approach prompt optimization like a machine learning task, where we treat the prompt itself almost like a trainable parameter and optimize it based on some training data. But how can we do that? It turns out that the simplest technique we can apply is called few-shot in-context learning. The idea is very simple. We just put several labeled examples directly into the prompt. For instance, to improve text classification, we can supply several text label pairs directly in the prompt alongside a very generic instruction. That way, we obtained a much better prompt without much of handcrafting. However, here we have a single component system. Applying the same technique in a compound system is not that straightforward. Why is it the case? Because in multi-step pipeline, we usually only have access to the initial input to this pipeline and the final output that's produced by a pipeline. But we don't have any intermediate input-output pairs between the modules. However, we can use the training data and a teacher model to construct trace and save the intermediate results that would be used at a later point as few-shot demonstrations. This approach is used by a technique called bootstrap few-shot. The idea is as follows. First, we run training input through our program. If the output is a highly scoring prediction as assessed by a specific metric, then we keep this trace. Otherwise, this trace is discarded. This process repeats until the maximum number of good or high-performing examples is collected. Before we proceed with other methods, let us zoom in into one important component of this process, the metric. The metric is what tells us whether a model's output is good enough to be saved as a demonstration. In simple cases, we can use traditional metrics, such as F1 score, accuracy, etc. But most real-world applications don't produce simple outputs. They usually generate long-form text, such as summaries, explanations, translations, and so on. For these cases, we can use another language model to critique or score the outputs based on some desired qualities. For example, correctness or some domain-specific requirements like adherence to a brand voice. Let's now look at another method for prompt after optimization, which is called bootstrap few-shot with random search. It's based on the idea of bootstrap few-shot, but it takes it one step further by searching for the best performing combinations of demonstrations. Let's go through how it works. First, we generate a set of good input-output traces. Then, instead of just inserting these traces into the prompt, we randomly sample different subsets of these traces. Next, each sampled combination is evaluated, and finally, we select the demonstration that leads to the highest validation performance. You might have noticed that so far the primary approach for prompt optimization was simply adding labeled demonstrations directly into the prompt without doing anything with the instruction. And it turns out that this method is quite powerful. In fact, some studies show that optimizing just the demonstrations can lead to better performance than optimizing the instruction alone. However, the instructions become more popular, more important in tasks with complex conditional logic. Moreover, joint optimization of instructions and demonstrations generally yield the best results. So how can we achieve that? One of the most well-known methods is called Multi-Prompt Instruction Proposal Optimizer, or MIPRO. It is able to optimize both instructions and demonstrations at the same time. First, we collect high-scoring input-output traces. Then, to propose instructions, MIPRO doesn't just rely on language model's internal knowledge, but it grounds it with some meaningful context. For example, summary of the dataset, overview how the pipeline flows from module to module, bootstrap demonstrations, and historical information about prompts and their evaluation scores. Finally, the best combination of instructions and demonstrations is found using Bayesian optimization strategy. This is a powerful method because it allows to explore a huge space of instructions and demonstrations and pick a combination that works best together. However, MIPRO might still be limited in one key way. It uses a single feedback signal to optimize all modules. That makes it difficult to improve prompts precisely. The optimizer doesn't know which module is responsible for a poor performance. Making an analogy with a deep learning, it's like training a neural network without gradients. You just try different things and see what sticks. The concept that might solve this problem is textual gradients. Just like in neural networks, we could backpropagate those gradients to quantify how each parameter contributes to overall loss and provide direction for optimization. Prodigy mimics this idea by using natural language explanations of what went wrong as textual gradients. It starts by running the initial prompt on a mini batch of data. Then it uses the first prompt template that instructs the language model to describe problems which could have led to these mistakes. This response is our semantic gradient. It points in the direction of what is wrong. Then the second language model takes that feedback and edits the initial original prompt to correct those mistakes. This loop continues recursively, and the most highly performing prompt is selected. TextGrad builds on the core idea of Prodigy, but it allows for systems of arbitrary depths and multiple trainable variables per prompt. According to some benchmarks, TextGrad can be on par or even better than Bootstrap few-shot with 8 demonstrations. Now that we covered some essential theory, I would like to hand it over back to Oleg, who will walk you through available prompt optimization frameworks and more practical code examples.
Yes, so when it comes to prompt optimization frameworks, without any doubts, the most popular one is dspy by Stanford NLP. As their own motto says, it's used for programming, not prompting language models. And indeed, in dspy, prompts are completely abstracted away from the users through a concept known as a signature. A simple signature might look just like this, which is just a string, and by looking at this string, we can intuitively understand that we want to have a question as an input and an answer to this question as an output. In addition to that, we want our answer to be a floating point number. To test that it works, we can create a very simple dspy program. First, we initialize a predict module with our signature, and we will talk about modules a little bit later. And then we call our module with the question, what is an average weight of a cat? And here we received 4.5 as an output, which is a floating point number. So it seems to be working. However, such simple string-based signatures might not be sufficient for more complex problems. For example, what if the variable names within our signature are not self-explanatory, or we want to provide an additional initial instruction to the model? But luckily, this can easily be done in dspy using the class-based signatures. For example, here we have a more complex signature where we want to check the faithfulness of the text given some factual context. The model should produce its answer and also a list of supporting evidence. In such signature, we provide an instruction as a docstring and the specifications of input and outputs as attributes. As you can see, the fields in the attributes can also be provided with optional descriptions. So how do we use such class-based signatures? Actually, we use them the same way as the string-based signatures by passing to the modules. And actually, under the hood, all signatures are being converted to signature objects anyway. But you might be wondering how or where those signatures are actually used. And to answer this question, we can actually check the raw messages that are being passed to the LLM. And here we can see that our signature got automatically converted into a rather long system message. It starts with the specifications of the input and output fields, then the description of the expected format, and finally the instruction itself in the bottom. So now that we more or less understand how signatures work, we can talk a little bit more about modules. In dspy, modules are basic building blocks. And if you are familiar with PyTorch or some other similar deep learning framework, you would find a lot of similarities. dspy supplies several pre-built modules. However, today we don't have enough time to go through all of them, but let's just check two. We are already somewhat familiar with the predict module, which is the simplest one. It just takes the signature and executes it without any modifications. An example of a slightly more complex module would be a chain of thought module that modifies our signature by adding an additional reasoning output field. This way, the model would always be forced to produce its reasoning before the final answer. And exactly like in PyTorch, we can create our own modules. For example, here, we built a simple chain that first translates and then summarizes the text. The final two components we need in order to optimize our module are teleprompters and metrics. Again, drawing an analogy with the PyTorch, a teleprompter would more or less correspond to an optimizer, which iteratively adjusts the instructions and demonstration within each submodule of our module that we are optimizing. And once we have a module that we want to optimize and the teleprompter initialized with a metric, we simply call the compile method, which is an equivalent of train or fit. So to sum up, in dspy, you would usually create custom modules using the built-in ones as the main building blocks, and also the signatures as abstractions over the prompt templates. The custom module would then be optimized by a teleprompter based on some supplied metric. And now let's take a look at another framework called TextGrad, which is also the official reference implementation of the TextGrad method presented earlier. Unlike dspy, TextGrad is actually rather low level and small and provides only a handful of blocks out of the box. First important concept that we need to know in TextGrad is a variable. A variable can be a full or partial prompt, then can be optionally optimized by setting the respective value of the requires grad. To use these variables, TextGrad provides a built-in black box LLM module that takes one variable in init for the system message and another one in the call for the user message. Now, in order to optimize our variables, we use the same syntax as we would in PyTorch. First, we initialize the optimizer, then we initialize the loss, then we calculate the loss, and in this case, the loss is just an output of a judge LLM. Then we call backward on the loss and step on the optimizer. So exactly the same thing as in PyTorch. And actually, this is more or less everything that you need to know about TextGrad. It's really simple and intuitive, but at the same time, some things cannot be easily implemented out of the box. For example, what if we wanted to optimize only a specific part of our prompt and hardcode the other one, or provide a few short demonstrations as in dspy? And this brings us to the last framework for today called Adaflow. Overall, it can be viewed as an extension of TextGrad, but with some things taken from dspy. Given that we don't have that much time left, we will only go through some of the most notable differences between TextGrad and Adaflow. So in TextGrad, we had variables, and in Adaflow, we have parameters. But now we have two different types of parameters: prompts to hold textual instructions, and demos to hold few short demonstrations. These parameters can be used in the explicit prompt templates. Hence, the prompt template can have both a static hard-coded part and a dynamic optimizable one. The functionality related to a certain pipeline can be encapsulated in a component, which is more or less exactly the same thing as a module. But finally, to optimize our component, we first need to wrap it into another ADL component, which is a special type of component that expects the component we want to optimize, the loss function, and the evaluation function. Finally, when we have our idle component, we can pass it into the trainer and call fit on the trainer. This might look a bit too verbose, but at the same time, it's actually not that different from what we've seen with other frameworks. So to sum up, IdleFlow is a very feature-rich framework that combines the ideas of TextGrad and automatic few-shot learning like in dspy. But in my opinion, it might be a bit too verbose, as we saw, which is not necessarily a bad thing, but at the same time, it might potentially imply a steeper learning curve. And finally, let's get back to the original question, is manual prompting dead? And as always, the answer is not that obvious. Without any doubts, automatic prompt optimization is a viable technique. It is fast, simple, and in most of the cases, still cheaper than manual effort. However, there are still some potential limitations. First of all, the underlying optimization technique is still based on the manually crafted meta prompts. And those meta prompts are not necessarily well optimized for your specific problem. In addition to that, by using the automatic prompt optimization, you are bound by the reasoning power of the LLM, which can be limited. Therefore, it might be a bit too early to declare the death of manual prompting for now. Yet, automatic prompting is a viable alternative, and we definitely encourage you to try it on your specific problem. And if you want to try it, but you don't really want to learn a new coding framework for that, at Dataforce, we have recently launched an open beta of our ML Studio, which also includes a no-code prompt optimization module. It is live, 100% free, and to be open sourced within the next 2 weeks. So you can access it using this QR code, and we would really appreciate it if you try it out and provide your feedback. And from our side, that's it, and we are ready to answer your questions. Thank you.
Thank you very much. So we have time for some questions for you. So do you think some models respond better than to the others to the previously presented prompted approaches? So can you rate some?
Yes. So basically, a general idea is that those prompt optimization approaches are based on meta prompts, as I said, and therefore the model that follows the instructions the best would be the best model to try for these things. And generally, those are the models from OpenAI, Claude, and so on. So the major closed source models.
OK. And are dspy signatures a kind of function calling?
No, not really. It has nothing to do with the function calling. Actually, basically, if you look at the, OK, maybe here. When you have a signature, in the end, it gets transformed into a system message that just describes what inputs the model should receive and what outputs it should produce, and in which format.
OK. What about an approach to prompt optimization based on genetic algorithms?
I mean, it could be done. I'm pretty sure. I'm not really familiar with the. I don't think that genetic programming is implemented into any of the big frameworks. But at the same time, Bayesian optimization is. I mean, it's kind of different, but the idea is the same. You just generate lots of instructions and try to figure out which one are the best.
OK. And could you share a practical task or use case where you would manually optimize the prompts and then move instead to the automated ones?
Yeah, so basically, I would say that the simplest task and also the most prominent in this case is classification, because here it's really, really easy to come up with a metric. You can just use the exact matching, and it's a well-defined task. Obviously, when you have some tasks that require more creativity, you can still use the automatic prompt optimization because you can use the LLM as a judge. However, it might be more subjective. Therefore, if you have a task with a strictly defined correct answer, then prompt optimization should be much, much better than the manual optimization.
Just because you shared something about the LLM as a judge now, somebody asks if we can use prompt optimization techniques with limited training data, perhaps using an LLM as a judge.
Yes, so basically you could use prompt optimization without data at all. You could even generate the data, so probably the answer is yes.
Probably. And can you expand a bit on text grad methodology? So how it is text modified to obtain a new text version after computing the gradients?
Okay, so in
That's
this...
a tough one.
I mean, it's not really a difficult question, but at the same time, I'm not sure that we have enough time to go into the details. But overall, the idea is that you get the natural gradient, and the natural gradient is basically a description from another LM what was wrong with the output of the current module, and then we pass this feedback and our current instruction to another LM and say, okay, so we had this instruction, we had this output, but according to another LM, this what was wrong with this output, so can you now modify the instruction so we don't have this problem in the output? And we repeat it continuously.
Okay, and last curiosity for our audience. Which of the presented libraries do you use the most in your daily job? So what's your favorite one and why?
My favorite one is Data Studio.
Surely.
But overall, dspy is way more popular than TextGrad and Adelflow. So TextGrad, as I said, is just a very, very small library. I'm not really sure that it's that convenient to use it in production. Adelflow is very promising, but at the same time, it's only an emerging thing, and we will see how it turns out in a couple of months or years.
Okay, so thank you very much, Oleg. Thank you very much, Irina.
Thank you.
40 minutes. Yes, yes, yes. And I will give you 2 and the end of 40 minutes. Okay. Thank you, everyone. Please, let's get seated. So, today we have the pleasure to have here Jorge Martinez Gomez, originally from Barranquilla, Colombia, the country of Egan Bernal, for those who follow a particular sporting event going around the cities of Italy right now. And he's now been settled in Rome for the last few years, working at the World Food Programme, collecting and analyzing geospatial data to handle emergencies at global level. And he will be telling us all about understanding geospatial data with DuckDB. Please give him a warm welcome. And as a reminder, you can ask questions using Slido at pycon.eit/Slido and also rate the question so that we will have the Q&A session later. Thank you. Jorge, food is yours.
Thank you for the presentation. So, hi everyone, thank you for attending the conference and also attending this talk. I'm going to give like the agenda basically is like, I'm going to divide it in like 2 parts. The first one is like a basic introduction about geospatial data and GIS in general to like make you like familiar with like the terminology and all the words the jargon that we use in GIS. And the second one is I'm going to move to a notebook and then I'm going to demo what we can do in terms of GIS with DuckDB. So that's going to be like the presentation today. So let's get started. And the first thing is like an introduction about what is Geographic Information Systems, or GIS. And basically is location data. Is almost everything that happens somewhere. Basically it has to be related to location. And GIS are systems that they can help us to like deal with geospatial data. So we can capture data, like for example, you fill a form, they can track you, or you can like send data across your GPS in the cell phone. And then you can store it. That's what we're going to talk about today, which is like geospatial databases. You can edit the locations. Also, you can make analysis of that data and also visualization and display that data. And the focus of this talk is going to be on store, analyze, and displace. This is going to be the focus of the presentation. And this is repeated. Anyway. So what is the data? The data can come in like many forms through various sources. So we can have like paper interviews, mobile phones, like airplanes, or satellites. For the people that are working with like remote sensing, like satellite imagery. And usually we have like spatial data and non-spatial data, which could have like tables. We have like points, lines, and polygons, which is like geometries. And also we have the pixels, like the pixels that we take from the camera. And the way we represent geography, we can have like 2 main types. The first one is better, like this. It's like discrete objects. So those objects are like well-defined boundaries, are like points, lines, and areas. Those like you can count those like polygons or those geometries, and they are like persistent through time. So for example, administrative boundaries. So usually the admin boundaries or the way the boundaries are set for the countries, they don't usually change, but sometimes there are like changes, and changes are needed to make them. But they are like persistent through time. And also, they don't represent, like, there are not like changes in values across the small distances. So for example, the boundaries of Italy is, they don't represent like the small changes, but if you switch, for example, vegetation temperature, that's a satellite imagery. So the value that you can get in 1 kilometer could be another value in the next following kilometer. That's like, in that case, when you have like discrete objects, those are not considered discrete. Those are like continuous fields. So those fields are like properties that like they change consistently over space. And usually the examples could be like soil moisture, water depth, temperature of the surface, and so on. So these are like the examples, like small examples. This is like an area of like vector data, discrete objects. This is like an area of some like farm. And these are like the most popular, which is like a neighborhood. So you can count, you can like vectorize, and then you can draw like lines or roads or buildings and so on. And for continuous fields, we have like elevation models, or elevation images, water discharge values, and also as I mentioned, the temperature, the surface temperature of the Earth. So these are like the main difference between like discrete and objects and continuous objects that we have. So vector data is used to represent like discrete objects. And we have the points, which is locations recorded as coordinates. So as we have like the latitude and the longitude, and those are like individual locations. So you can draw the points, and then you can display them on a map. The lines are like a subset of points. So you can like draw one point, another point, then you can make them together, and then you can create a line. And finally, you have the polygons. So you have the lines, and those lines are close ones. So polygons are considered like line strings, where the first value of the coordinate is the same as the last value of the coordinate. So those are in closed string, and those are considered polygons. And vector data is like spatial data, but the data that we use for vector data consists on two parts. The first one is the geometry itself. So it gives us like the spatial information, the line string, or the polygon, or if it's a point, and so on, and the values in terms of like the coordinates. And they represent the shape of the phenomenon. So in this case, these are like the shapes, and the additional information is called the attributes. So the attributes as like information that is like additional to the geometry. So let's take an example of this one. So we have like these polygons that they represent buildings. So the geometry is like, it says, okay, it's a polygon, and these are the coordinates of the polygon. And the attributes, or they are also considered properties, are like information about the address of the building, the number of the building, the number of floors in the building, the roof type, and so on. So these are like attributes. And then if we combine the geometry with the attributes or the properties, we can create something called a feature. So geospatial data in terms of vector data is like a collection of those features. And then that's the one we manage and then we work with. So not necessarily you can have like only points, slides, and polygons, but you can combine them. You can have like a point or like an array of points, which is a multi-point, or you can have like multi-line strings, or you can have multi-polygons, or also you can have a polygon inside another polygon, which is the polygon with holes that are like shown here. So you can combine them together, and well, these are like considered geometries. For raster, it's different because we represent like continuous fields. As I mentioned, you can have like values that change in small distances, like as I mentioned, the temperature. And this information is like stored in like similar to images because it's like an array of numbers, which is like the pixel, and each pixel represents one value. And you can represent the value can be different types of values. For example, population count, population density, yeah, you name it. But those values, they have like a fixed distance, and each pixel represents one fixed distance. For example, you can have this pixel that represents population number on an area of 100 meters, but you can have also the same value of population number, but the area of the pixel represents 1 kilometer. So you need to like check and track what is the size of the pixel, what does that pixel represent in terms of like area. And there are like changes like vector and raster data. But before I continue, I'm just gonna move to desktop app, which is of QGIS, so we can like see better and to make the difference between vector and that raster data. So I have like here 4 layers. I have the administrative boundaries of Colombia for the admin 0, which is the country itself, admin 1, which is the departments, and admin 2, which is the municipalities. And I also have the population raster. So this is the admin 0. As you can see, this is the admin 1, and this is the admin 2. Yeah. And this is the population raster. So if I want to select one, let me just check this admin 1. And I want to see the attributes, I can just go here. This tool makes it like easier. Oh, let me just make it like this, better. So if I select this one,
it will show me, this is like the geometry of this feature. I have this array of, this is a geometry collection, sorry, a feature collection. When I select one feature, and then I can see here, you cannot, I guess, but you can see information about the administrative name, the administrative code, what is the country belonging, and so on. But the attributes for this admin 1 are like different if I select the admin 0. So if I go to admin 0 and then I select it, I have the whole geometry, but I have other types of attributes. So when you manage and you work with geospatial data, make sure that each element in that collection is consistent with all the attributes and geometries. That's ideally. I mean, in theory, you can mix it. You can mix polygons with points and polygons with different geometries, but when you want to work with that, it could be like really complicated. So it's better that you isolate the data using the same geometries and also using the same attributes. I'm working right now with vector data. But when I move to raster, which is over here, this one, so this is the population raster level, and then if I zoom in, the more red it is, the higher the value of the population. And then here you can see like the image gets like pixelated, and each value of each pixel represents the population that I have across that area, and I know that this area is 1 kilometer. So this is the amount of value that I can get in 1 kilometer in that region. Okay? So now, going back to the presentation, the way that you want to work with geospatial data, it like depends on the application that you want to do, or the thing that you want to do. Sometimes vector suits better, sometimes raster suits better. The way you work, the way you share that information also depends. And some vector, they can be like transformation. You can convert vector data to raster, and also you can, and vice versa. Now that we're talking about DocDB, DocDB is like a database for managing data. You can have data as tables, and now we're going on that, but it only supports vector data. That's something that you need to be aware of that. And as I mentioned, you have like when you create a map or you create a web map, it's like an integration of different data sources. You have, as I show you, you have like admin 0, admin 1, and admin 2, and each one goes above the other. And you have like you can create like a combination of those layers or those like tables, and then you can have you can assemble or you can create your own database. So you can have a combination of like each data source. Each one has is a collection that has features, and each feature has the geometry and it has the attribute consistently. And also you can collect and stack them together, and then you have your database. So that's in few words what is like a geospatial database: a collection of features, sorry, a collection of layers, where each layer has a fixed array of features. And now we're going to DocDB. So this is the second part, and I have shown you, I just created something called a notebook. Let me see if you can see better. It's better. So this is a notebook, and I'm just going to explain how can we use DocDB to manipulate geospatial data. So as an introduction, DocDB, as I mentioned, is a database where you can like create tables, and then you can manipulate tables. The good thing about it is that it's like different to Postgres. You don't have like an application itself, like a binary that you need to run, and then you can connect through username, password, port, and so on. The thing is that you start from a scratch database or a persistent database, which is a file, and then you start including or removing data. So you start empty, and then you start creating and improving data. So the main goal is how to work with geospatial data inside DocDB. There are many different ways to do it, but I'm going to show you the one that has been like easier for me. And the first thing that you need to do is like, okay, we import DocDB here, and I'm using additional libraries for like displaying data and so on. I'm gonna explain later. So we use DocDB, and then I just create a normal connections. And with this connection, I just start appending the extensions that I need. So I'm just gonna use two. The first one is spatial, so it's the library to manipulate geospatial data or the geometries that we have been talking before. And also the HTTPFS, which is the one that we're going to use to load data remotely. That's the one we're going to use. So remotely doesn't mean like a standard HTTP static site. You can also have like your files in S3 buckets or your data in S3 buckets, and then you can just set up the connection inside DocDB, and then you can retrieve that straight away. So when I run this, you can see that I have just include the connections. Include extensions. I install them, and then I load them. And finally, I run this command, which is describe tables. So this table only shows me that I don't have anything, which means that the database is empty. It's an empty database. I don't have anything. I will start right now including data. Okay? So as I mentioned, vector data is spatial data. You have the geometry and you have the attributes. And they represent the shape. And now I'm just going to start creating geometries. So this is the function to create a single point. So this is a query. And as I forgot, DocDB supports, works with SQL language. It's a dialect of SQL, and then you can perform queries normally as you can use similar to Postgres. It's not the same to Postgres, to PostGIS, but it's quite similar. So this query basically creates a point. So this is a point. And when you create it and then you run it, you can see that this column is named geom, and the type is going to be a geometry type. Okay? So you need to be aware that this must be a geometry to start operating with geospatial data. And I can continue working on that. So now here I'm just going to apply small operations across the geometries. In this case, I'm just creating a line string here. So, sorry, my mistake. So I have the point here, and what I do is I evaluate the area of the point, the length of the point, and the geometry itself. So these are the results. And the area is 0, the length is 0, and this is the point. But in this case, I just make a line with an array of points. So this is the line string that I create, and then I just evaluate the same result. So here you can get the query that I create the line string, and here you can get the query to get the area, the length, and the geometry itself. So for this case, the area is going to be 0 because it's a line. The length is going to be the length of the line. In this case is 5, and this is the geometry that I'm using. But if I make a polygon, which is this one, this is the query, the subquery that I used to make the polygon. And the area is going to be the area of the polygon, which is fine. The length is going to be 0 because, the length of the polygon. And this is the geometry that I'm using. So these are the values that I could get, and these are like the types of operations that I can do inside a query. So the benefit of using SQL is that you can start creating subqueries one after the other. So you can do some sort of analysis, and at the end you will get results, and everything is going to be stored in a single query. So that's like the benefit of like using DocDB compared to normal tools and libraries that are used in geospatial in Python. Because, for example, with Shapely, you need to download the information, and then you need to separate the attributes from the geometry. And then you need to have the geometry as a Shapely object, and then you need to operate and do the things that you need to do, and then you need to go back, and then append the attributes. So it's kind of like a complicated, and I'm going to explain you why. Now that I have a CSV file. So this CSV file represents something that we work in WFP. It's called RWI, which stands for Relative Well Index. So I have the latitude and longitude of a point, a location somewhere, and that relative well index indicates the level of wealth that can have in an area of 2.4 kilometers. So I have the point, and I have the area 2.4 kilometers, and this is the value that I can get. Negative means that it's like the wealth is like not good, and positive means that it's good. So the higher, the better. Okay. So this is the data, and this data is stored in a CSV file. I have it here. This is my CSV file, and then if I load it, I can load it straight away in DocDB using this query. So select star from read CSV. The problem with this is that this table right now, the way it is right now, is not geospatial. As you see, it's like a latitude and longitude. Those are like doubles, and those are like numbers. So now we need to like make them geospatial. So what I do is that I can just create the same table here, But what I do is like I take the longitude and the latitude columns and then make the point of it. So if I see again and I want to describe the table, you can see that the geometry here is the geom. And let me show, I think I show it here. That's the cool thing of live coding. So here you can see the RWI value, the error. We're not going to use for this presentation, but this is the point that we created before. So I took the 2 columns, I make a point, and now for DocDB, the tool will understand that it's going to be a geometry itself. And then I can start working with it. So something to talk about before continuing is geospatial formats. So as I mentioned before, data, the vector data, is like classifying 2 main fields: the geometry and the geometry and the attributes. But that data, the way you serve that information, the way you share that information, or the way you read that information, could be, you can create a huge JSON when you can have each field, or you can have a CSV file. You can have many ways to serve it. There are like infinite ways that you can serve that information, right? So there's an organization, it's called the OGC, Open Geospatial Consortium. So what they have dedicated most of the time is to develop some sort of a standard or a structure, or how you need to serve or you need to generate that data, or how you need to read that data. What is the advantage of having a standard for that interoperability? Which means that, for example, I can have that information as a GeoJSON file, and then I can have it stored somewhere, and then I can use any web map client that can read GeoJSON, and then I can just load it. I can just put the URL that I need, and then I can just load it, and then I have my web map beautifully visualized. So I wanted to show that because there are so many formats that you can work with. There are many ways, and that's another advantage of DocDB. So internally, DocDB has it's called the GDAL. So GDAL is like a library to operate geospatial data, and they support many formats. What's the benefit of that? Is because you don't need to think about which is the library. You don't need to think about which library, or you don't need to install the library that, depending on the format that you need to use it, right? So there's a library for shapefiles, there's a library for GeoJSONs, there's a library for GMLs, and so on. So you need to install it, and then you need to operate and do the things that you need to do, parse the data, and so on. With DocDB, it's just a single strread command. So here, let me show you here, this one. So here I have the URL of a GeoJSON that is showing the same data that I show you here in QGIS. Sorry, yeah. So these are the boundaries. And then what I'm going to do is I have these boundaries remotely. And the query, what it does is I just create a table called boundaries. And basically, it's just reading from the URL. So it internally parses, checks what is the format, and then parses it automatically, and then creates the table. So I have 2 URLs, one for URLs for municipalities, which is admin 2, and then another URL for admin 1. And then I just create the tables, and then I can just see what is the data inside the tables. So this is the case for boundaries, which is the admin 2. But if I switch to admin 0, yep, this is the admin 0, and if I use the admin 2, I can see all the attributes that are inside that file. And also, I can see what is the geometry that I have inside that file. So it's easier to operate. And now that I have the table, I can start combining tables. I can start operating, and everything is going to be inside an SQL query. So simple operations of data, I can just filter by an attribute. I can, for example, in this case, I want to totalize the number of admin 2s given this column name. So this is the value, and then I just count, and so on. The same for the other table, the RWI table. You see the points and the RWI value. I want to get how many points are below 0, have -12. So everything is inside as I mentioned, at the beginning you started with a connection in memory, which was empty, and then you started including data. And each data is organized on tables, and each table has its own set of attributes and geometries. And then once you have everything consistent, you can start like combining and making joins and so on. So this is an operation that I do across the attributes. And this is an example for visualizing the data. So here I'm using like just create a small 2 drop-downs. So one is for the admin 2 and the other one's for the admin 1. And if I go here, yeah. So this query, what it does is I'm just going to get all the geometries from the boundaries, and I'm centering them a leaflet map. And what I do is once I get the data, I just create a geodata frame of the query that I need. So in this case, I just want to get all the RWI values, the first 5,000, and visualizing the web map. So here, you can see that this is like all the boundaries that get at admin 2 level, but also you can see the points for the RWI values, the first 5,000. So the cool thing is that I can just, if I want to change the table, I want to use is admin 0, I can just change what is the table that I want to get the data, because I know everything is like standard, and the geometries are standard. I just change it, and I can just show the admin 0 with the same points. But if I want to show only the high ones, RWI higher than 0, limit, I don't know, the first 500, and I run the query, you can see all the points that have that RWI value. So it's operations across the attributes, and now you can also do operations across the geometries, which are called geospatial relations. So you know that you have one table, which is a list of points, and then you have another table, which is a list of polygons, right? So you have the RWI, and then, for example, you want to know what is the amount of points that are inside a given polygon, okay? So in this case, the spatial operation is going to be within. So I'm going to find which are the points that are within a given polygon, right? I have the 2 tables already in the database, and now what I'm going to do is I'm going to select here in this query, I want to select what is give me the geometry that matches the given admin name, okay? Here, I'm using just to extract the centroid. I just want to center the map where I want. So I take the geometry, and then I just compute the centroid, and then extract the latitude and longitude. And then I have another query, which extracts the geometry that I want, and then I perform the operation that I need. So here, you can find that this is the operation that I say, OK, I have the geometry of points from the RWI table, and I want to find which are the points are within the boundary that I filter, okay? And once I filter, I'm just going to get the data. I'm just going to and then plot it on the map. So this is the result that I get. And the cool thing is I made the drop down. So if I'm showing Barranquilla right now, but if I want to select another city, I want, for example, Cartagena, I can show which are the points that are within that polygon. Sorry, which are the points that are within that polygon. And then I can just continue it. It will be like a standard. So move to Medellin, for example, and here you can see it. So that's the way you can like operate at an attribute level. But it depends on the geometries that you use. Also, it depends on the type of analysis that you want to make. You can, be creative. You can find intersection of polygons, union of polygons. You can combine polygons together. You can make a line string given a set of points. So those are like the usual geospatial operations. Yeah, operations, but it depends on what you want or what you need to do. Okay. Continuing, projection. So what happens is that the main problem that we face in GIS is that the world is considered like a 3-dimensional spheroid, and when you want to display is a 2-dimensional plane, canvas, right? So the way you represent or the way you transform that information, you will have some sort of loss, or the information will be like distorted. The best example is the Antarctica. So in the south, imagine that you take the world and then you unroll it, and then you put it in a canvas, and then inside that canvas, you see that the Antarctica is like stretched. So it's stretching the higher latitudes and in the lowest and the highest latitudes, and then you will see like the data distorted. But that's a way that you represent the data. Because instead of that, you can use You can rotate the world, and then you can just show the plane or the way you visualize it, centering the information in the Antarctica. In that way, that information is going to be visualized in that way, so the data is going to be better for that location. But for globally, everything is going to be like around points. So that's a problem that we usually face. And also, each way you represent the information, it will have its own measurement units. So for example, this projection, which is WGS84, the values or the metrics that are used are degrees. But when you use another one, like the Google projection, they use like pixels. And there are some other projections that they use like units in meters. So it depends. It depends on what you want to do. It depends also on the extent of the data that you want to use. If you want to globally or you want to center across a country or across a region, you can need to reproject or not. So let me show you an example that I have. I mean, the end goal that we have is I want to know which is the total population that is that has like low wealth in a given city. That's the end goal that I want to do, and I want to use I want to play with operations to do that. So, as you see, the query gets like more bigger. So, what you do is, okay, this query, what it does, I want to find the squares, or I want to create squares that represent area 2.4 kilometers. So, the first thing that I need to do is to find the wealth values negative for a given city. And then from those points, I will create a buffer that is going to be a square, and that square is going to have 2.4 kilometer area. The problem is that the projection of the points are degrees, and the other ones and the ones that I need, the value that I need to create the buffer is in meters. So what I'm going to do is just reproject to 1, then create the buffer, and then go back to the previous projection. So this is the query as it gets a bit complex. So here I do the transformation, then I create the buffer up here, and then I can go back here. So I make sure everything is in a single query, and then once I get that, I will get the extracted geometry. And then I just plot it here on the map. So here's the example of like Medellin. So here you can see which are the areas where the wealth index is like lower. It's like below than 0. Because I applied the filter here. The RWI is higher than 0. Sorry, it's lower than 0. So this is like the way, but I can change it if I need to. And if I switch city, for example, Barranquilla, you can see like these are the areas where the wealth index is like low, below 0. So yes, now I have the areas. And now I need to pass the population information because I know the areas and I know how to pass the population information. But that information is a raster, okay? Because we were playing with vector data and we don't have rasters, right? DocDB doesn't work with rasters. And the population is a raster. The operation that we need to do is called zonal statistics. And this is like a small diagram, which what we do is, okay, we have the location of the boundary, and then we just overlay the boundary with the pixels of the raster, and then we select the ones, the values of those pixels that intersect the boundary, and then we just compute statistics. So we can compute count the number of pixels, we can count what is the maximum value of the pixel, we can count the sum of the pixel we totalize, we can compute the statistics that we need to, right? So for this case, we need to totalize. But we cannot work straight away in DocDB. So there's a big problem. However, there is a solution. Python has a tool to work with rasters, and then you can compute zonal statistics. But the advantage of DocDB is that when you don't have a function that does what you need to do, you can just create a Python function when you pass some sort of parameters, and you can inject that function into DocDB. And once you inject it, you can call that function, and you pass those parameters, and then it will run inside, and then will return the value that you need. So that's a huge advantage, because whatever we don't have inside DocDB, we can just create a custom function, and then just use it. So for this example, I'm just going to use a library called rasterstats, which has this function. And this is the zonal stats function, zonal stats logic that it does. So this is the function that I create. I just pass a list of geometries, which is the squares that I showed you before, the squares for a given city. and I pass the path of the file of the raster that I showed you in QGIS. So I do it there, and then I compute the function that I need, and then I just totalize. So what I do is, okay, for each square, I'm just going to get the sum of the pixels of the population for each one, and then I just sum everything, and that's the value that I'm going to return. So this is the information that I get, and then I just show you, I mean, this is like the whole complicated query that I showed you before, but what you need to be aware is that this line is the line that I say, okay, DocDB, this is the function that I'm going to create, this is the one that I'm going to name it, and this is the function I'm going to use. And then, once I know it, I can just pass it here. So this is the function that I created, the custom function. I just pass the geometries that I received from the subquery, and then the path of the raster that I have locally in my computer. So in this way, I can just run a custom function in Python as a SQL command, as a custom SQL function. And so on, I can just run it, and I can get the result that I want. So for example, I have the drop-down before, and the city is Barranquilla, but if I want to switch for Medellin, you will see the value of the total population. So all the squares were like computed, and everything was done and recomputed and so on. So yes, that's a big advantage that we use in DocDB. And to finalize, because I have 5 minutes left, how do we apply this inside WFP? This is like a brief demo of an application we call Prism. So Prism basically is a tool for like monitoring hazards and emergencies. And one of the features is that we have like tropical storm data. So tropical storm data basically is like a big polygon, which when each polygon represents like a wind buffer. And we have here the locations of the points where the storm is going around. So we have the data source, and each 6 hours, there's like a source. They are like emitting like a report of where the storm is passing through. So it's like a big GeoJSON. We just grab it, we parse it, and then we just show it here on the map. The thing is, once the storm makes like a landfall, I mean, there's like a forecast of a landfall of a storm, as shown here, we can do additional analysis. So we take the landfall, we can compute where is the landfall of the storm, at what time the storm could fall. If we have the storm, what is the wind speed values across that, and we create buffers, and so on. We can just synchronize with the administrative boundaries to know which are the districts affected. So it's like a mix of geospatial operations when you overlay things, and then you can just have that's like table of like the district with the number of people affected by so on. So this is like an application. And also the advantage of DocDB is that as it is like a wrap, it's not like a wrapper of a library in C++. It's like a tool that is like compile itself in Python. You can just install it, which can take like seconds, like 5 to 10 seconds. And then you can just run it as a Lambda. So we have a Lambda running, checking for new events. And then once it's done, we just run a DocDB query that creates the data and store it as a GeoJSON. And then we serve it over S3. And then we just fetch here in the dashboard. We can just visualize that data from S3. So hope it's clear. And thank you. That's
Thank you, Jorge, for the wonderful presentation, and finished actually almost 2 minutes early. So yeah, we have times for questions. I recall it's pycon.it/Slido. We already have a number of questions. And let's start with the first one. And if you want to raise your hand, if you've asked the question so that the speaker looks at you when he answers that, feel free to do that. The first question is, what's the advantage over GeoPandas?
So GeoPandas uses internally the GDAL library. So in order to compile GeoPandas, you need to have GDAL installed. So installing GDAL, sometimes it's like a bit complicated. It's not like quite easy. And DocDB, when you install it, it has already the GDAL driver integrated. So you don't need to worry. You just need to load the extension straight away. That's the main difference.
Thank you. What are some good starting points to find geospatial data that I can experiment with?
It depends on the application that you want to use or the thing that you want to use. I mean, for the humanitarian sector, The most common is the HDX, the Humanitarian Data Exchange. So this is like a repository where people can like download geospatial data if they want as a shapefile and so on. But there's another one which is OpenStreetMap. The thing is that OpenStreetMap has a different data structure to manage geospatial data. So it could be like a bit complicated to work with, but DocDB has support for read OSM data.
Okay. Thank you. What are some good starting points? No, sorry, please read it already. Is there support for binary formats such as GeoParquet? Is it a format you recommend, or do you prefer to use GeoJSON?
That's a good question. So GeoJSON, I forgot to show that. So the way that you display the GeoJSON data is this way, which is this one. So all the attributes are stored in a field called properties, and the geometry is stored in this way. So it's a big JSON. And when the JSON becomes like really, when the data that you want to manage is like really big, for example, admin 2 level of a country is at a global level, is going to be like a huge GeoJSON. GeoParquet has the advantage that you can do Hive partitioning. So you can partition the data the way you need, and everything is going to be stored in folders. So depends on what you want to do, but for global data, it's better to use GeoParquet. And also there's like flat GeoBuff, which is the data is also indexed internally, so you can use it also. It could work.
Thank you. How can you embed what we have seen in a web app? For example, how did you do it in the Prism app?
Can you repeat the question?
How can you embed what we have seen in a web app? For example, how did you do that in the Prism app?
Okay, so as I mentioned before, we had a script, a Lambda function that is checking for new events, for new storms arriving. So once the storm arrives, we receive the information, we check for if there's a landfall or not, and then the analysis output, we store it in an S3 bucket. So we have the Prism app, and the Prism app, what it's doing is reading straight away the bucket from the bucket, and it's basically a GeoJSON output files. And then we don't need to parse it, we just need to fetch and load straight away.
Okay, I think we have a few more minutes. It's 25, right? Will you be sharing slides and notebook, maybe on Discord?
Sure.
Another question. Why there is a single geometry type instead of 3 different types for points, lines, and polygons?
That's a good question. So for DocDB, DocDB enabled the spatial extension, the spatial functions, and they only consider everything as a geometry. That's good and bad at the same time. Good in terms of like, since everything is a geometry, you can just operate over geometries and fine. You don't need to worry about consistency and so on. The bad thing is that sometimes you don't know what you are reading or what you're inserting, what type of geometry you're working on. That's the main difference with, for example, PostGIS. Because PostGIS, you can create a column that is a geometry, and you can force what is the type of the geometry that you're going to use, and also the projection that you want to use, the spatial reference system. So sometimes if you have a table of points and you want to insert a line, PostGIS will say, no, I won't do it. But for DocDB, yes. Maybe in the future, I don't know, for the DocDB developers will like force that, but it would be sometimes good for some occasions.
Okay. What notebook app are you using?
That's a good question. So I'm using called Marimo, Marimo Python. Not sure if someone is like have heard of it. So it's like a new version of Python notebooks. And the main difference is like when you make a change in one cell, it can affect the down ones. So that's a better reactivity. So when you want to create dashboards and you want to do things, Marimo is quite good. So yeah.
Thank you.
That's the one.
Yeah. What's the overhead of using Python functions in DocDB? Getting technical.
I haven't tested, honestly, I haven't tested yet, but I mean, what happens is that when you create a function, the function goes to Python, like goes to Python domain, performs the computation that needs to be done, and then goes back to DocDB. Not sure how fast it would be, but I don't have the answer, honestly.
Mm-hmm. And still on this, how do you debug the queries with an injected function?
How to debug? I'm using prints.
As don't we all?
I'm using.
Can I integrate DuckDB with multispectral data, like the ones from Copernicus Sentinel? Should I also use libraries like RioXarray, etc., or DuckDB can manage this data?
I think Copernicus data is raster level, so raster level is not like easy to work with DuckDB. You need to have like custom functions to operate with raster. But if you use DuckDB, you can just create custom functions that call the raster library and then do what you need to do there.
Okay, last one. Is there a way to use DuckDB and spatial library writing actual Python syntax instead of SQL-like?
I think not. I think DuckDB DuckDB accepts only SQL queries. They have a special dialect to run queries in SQL. But there is another library called SQL Glut. Not sure if people are aware of this. So SQL Glut, what it does is like, imagine that each subquery that I do is considered like an object. You have an object, and then you can just create a tree of objects when you can connect one object to the tree, and then or another object to the previous one, and then you can just and then everything, once it's done, the tree is parsed and then transformed into an SQL query. So internally, it's going to, at the end, it's going to be an SQL query, but everything is going to be created dynamically as an object. So for APIs and everything, it's quite good.
Thank you for the excellent talk and for the answering a lot of the questions. And please feel free to reach out to Jorge now, and we'll switch to the next talk. Ivars Calvans is a software engineer with extensive experience in the fintech industry. He's someone who is able to tinker with internals of databases and create open source alternatives to existing ones. You can ask him what a Faxido is. He will talk about what happens when databases receive a query and they start thinking about what to do, and he will put this in context of Django applications. Ivars is coming all the way from Latvia. I was recently at PyCon Lithuania, and I learned that Latvia and Lithuania, they have a similar size, and so they compete on a lot of stuff. And as far as I know, there are no Lithuanian speakers at this PyCon, so for this round at PyCon Italy, Latvia wins 1.0. Please give a warm welcome to Ivars.
Okay, thank you. Well, at least Lithuania have their own PyCon. Latvia does not, for years already. So, shortly about me, I spent more than 18 years working with Oracle, and we had to squeeze out every bit of performance and had to come up with creative solutions for the real-time payment card processing. So we worked with all kinds of technologies, like old spinning disks with like consumer-grade IDEs, and then the commercial kind of enterprise-level SCSI setups, different RAID configurations, network-attached storage, and then finally SSDs came out, and then it was like, oh, well, our job is done, so it runs pretty fast. It should be good. So now I work for a different company, and we use RDS and AWS, and guess what? We still struggle with query performance, and I guess most of people do as well. Before I go forward, I hope you can read, the letters are quite small, but I mean, the correct answer to the question, how do you improve database performance, is always, it depends. So I'm showing you this because I will try to give you more specific suggestions that might work in 95% of cases, and if you find some of those 5% cases, then don't blame me. I warned you. So let's go into the topics. And all this came out of trying to optimize some queries, and I discovered some new things about Postgres for myself. So, but first, let's go into theory a bit to understand how the database thinks. So all data inside the database is stored on the disk. It's called a heap. It's organized in blocks. So blocks in Postgres typically are 8 kilobytes. And this block contains rows. Sometimes rows might span multiple blocks. But the idea is that these are blocks, and they are on the disk kind of sequentially. So if you know something about the hardware, then reading something sequential from the disk, from the memory, is always faster than just jumping around. It was true for the spinning disks, and it's, to the lesser extent, it's still true even for SSDs. So whenever a database has to find something, it has to scan through the whole data inside the table. So it's not fast. So what's the solution? The solutions are indexes. So these are not binary indexes. These are balanced trees. And this is like a quick lookup structure. So it works for, just to be clear, it works for equality and greater than, less than comparisons. And how it works, so there's a tree. So if I want to look up key, let's say 18, then I start at the root node. I have to find an entry at the root node that is the largest value that is still less or equal to the one that I'm looking for. In this case, it's 15. It says me that I have to jump to the right node. I go to the next level, and there the value that is less than or equal to what I want to find is 17. So, and then this middle pointer points me to the block, and inside the block, the database goes through all rows until it finds the one we are looking for. Yeah, so just a quick note about what is stored inside the data. For a lot of databases like Oracle and Postgres, it stores some kind of identifier of the physical block where to find the row. There are databases like MySQL where all data, so they do not have the table as a heap. Their data is organized in the index structure based on the primary key, and then these data parts contain the whole row of the data, and secondary indexes in that case just contain the value of the primary key. So secondary indexes in MySQL do like 2 index lookups. And yeah, so here it points to some data block, and inside data block you can find the value 18. So this is how it looks in for a single row. In practice, if you look down at it, and especially it's for the Postgres, because Postgres doesn't update any row in place, it always appends new versions of the row, and then it does this vacuuming, which moves data around. So typically you end like with a complete random. So there's no, it doesn't preserve the insert order or anything like that. So this brings us to how the database chooses between going through the table or using the index. There are 2 main parameters. So one is the sequential page access cost. So how much does it cost to read a single block in a series of multiple blocks? So it's typically 1. So it's kind of the base value. And then there's the second one, which says how much does it cost to access a random page. If you think back to the spinning disks, you had to spin up the disk and then move the head to the specific location. So definitely it's much slower than just reading the next block that follows. So the cost there is 4 by default. And in documentation, it says that the actual cost is closer to 40. But the Postgres assumes that 90% of the random reads will go through the cache. So therefore, it's 4. And in the same documentation, they suggest to have 1.1 for SSDs. So that's the documentation. Now we have Postgres in AWS. Can you guess what is the cost of random page access? No, it's 4. It's the same default. So inside AWS, and I mean most Postgres instances work as if they would be running on a slow spinning disks. And then there are some other costs which Postgres uses, but those are, compared to these page access costs, those are like minimal, so we can ignore them. And the choice between the index and table scan is mostly based on those page costs. So whenever I ask, for example, in this my demo case, I ask for all values between 17 and 21. And then the database thinks, so the database estimates, tries to choose which access plan would be faster. So if it thinks about scanning the whole table, it knows the number of blocks it would have to read, and it quickly calculates that it would cost it 8 parrots, or whatever the unit is. In similar way, just for a reminder, this is how my example setup looks like. If I want to read the same from the index, so the quick estimation, so I'm leaving out the costs for accessing the index itself, so that's a separate topic, and that's complicated calculations, but it doesn't affect the main idea. So if the database thinks that it will have to access 4 rows through the index, so it will have to read 4 blocks, so it calculates costs by random access, and quickly already on the 3rd row, it thinks that, oh, it will be much more expensive. So of course, this is a small setup example, but just to give you a quick idea how database thinks internally. So from these costs, then, I mean, it should be obvious that accessing a single record should be faster through index, because and although it pays these random costs, it's single index, so it should be faster. Accessing the whole table should be faster through scanning the whole table, because it's sequential costs. And then there's something in the middle. So most materials say that it's a single-digit percentage. So if you are accessing, let's say, up to 2-3% of the whole table, then it will be faster through the index, and for the rest, it's faster just to scan the whole table. And this boils down to this sequential versus random access, which is 1 to 4, and then there add to that access and reading the index itself. So that's the reason why database often chooses to skip your indexes, even if you have them. And then the other observation is that database is often bad at estimating those numbers, and sometimes it's that the developers know better. Quickly, so also for creating indexes, so just because each index has its own kind of, each index has like initial cost to use it for the database, then of course database would prefer single multi-column index instead of multiple indexes. So it's hard to force database to use multiple indexes on the same table. And the typical advice is to index high cardinality columns and not to put indexes on low cardinality columns. So high cardinality might be your phone number, email, if it's like a user table. For low cardinality from financial institutions, so it might be like true, false, or even the currency code, because those currencies are very skewed. So typically USDs and euros are the majority of transactions. So if you have low cardinality, in case of Postgres, then probably partial index might be a better fit, just to kind of, if I look at the database and I see that there's an index on the low cardinality column, but it's a partial index, then I kind of assume that developer knew what he was doing, he or she. So that's kind of theory, but let's practice. So I use Django here, but I mean, it applies to all programming languages. It's just a bit different syntax. You can do the same from SQL prompt. So what I have here are two tables. So one is the member table. So most importantly, there's the name with index on it. And then there is document in one of 3 states. So it also has an index. So it should be probably like partial index, but I will show how I need it like this. And then I have a JSON field, because I want to show you how to create indexes in JSON as well. So now I generated some data. So I think I started with 10 rows. It didn't work as I wanted it to work. Then I generated like 3 more thousand and probably some more thousands. And the main key takeaway here is that in a perfect world, you would try to optimize queries on a clone of your production database, because it has the right amount of data and it has the right distribution of data. And as close as you get to it, the better. If you need to have like some private information removed, fine. If you can like get it as close as possible, that's also good. So we have some data. Let's do some queries. But first, like how to understand how database is thinking how it will execute the queries, because the queries are written in like declarative language, and it's up to the database to interpret it. In Django, there's this query set .explain. From the SQL prompt, you just can simply write explain and then the SQL query. So the most simple example is like this. So you have so this is Django ORM query. You put explain there and you print the result. So it says that it will use index scan on this, using this specific index on that table, and that's the index condition, which basically describes kind of what the index contains. So what's most important is that it also writes, kind of prints out the costs that the database estimated, how much it would cost. But remember, those are just the estimates. So much better way is to add this analyze equals true, which will cause the query also to be executed. And then once it's executed, you also get the actual time back, the actual number of rows, and what's more important, you get the execution time. So there are a lot of cases where database thinks that the cost actually will be much, much higher than it is. So if you do some tuning, you should be looking at this execution time instead. Now, just another example. So I'm doing like case-insensitive search here, and it says that it will do a sequential scan on the table, and the filter condition is this upper name, so on. And in a nutshell, so if it says sequential scan, so it means it's going through the whole table, and what it writes on the filter, it means that the database failed to find index for this index scan, then it's good most of the time. There is, for me as an Oracle guy, it's really strange that Postgres actually stores index null inside indexes, so that was a big discovery for me, but it does. However, although we have index on this column and we have condition on this column, so database doesn't use index here, you could probably see it also from the costs because it estimates that it will return quite a lot of rows. But I mean, the external ID is kind of, it has high cardinality, but the problem is that although the field itself has high cardinality, the expression itself is low cardinality. So what are the outcomes? True and false. So it's Boolean 50-50 on average. And there's this interesting talk I saw at the DjangoCon. There are some implications of Postgres storing null values inside the index, so it makes indexes unnecessarily large. So if you have time, look at it. So better handling of null indexes, I like to use conditional indexes, but I create indexes on some other field and then add this is null as an additional condition. I like to do conditions on soft delete so that the index contains only the rows that are not soft deleted. And the favorite one is that on some date, let's say I have a page where I have to display the events for the last week or last 2 weeks, then I create index that includes only the last month, and then I recreate the index once in a while, and so it gives me quick access to the last week's data, although the table might contain, I don't know, even years of data. And yeah, so I created this index, and yeah, so it's now, although we have conditioned on the name and external ID, the index itself, the index condition is only on the name, and then Postgres knows implicitly that this index will contain only the rows that with external ID equals to null. Then another thing I want to show is about, so we had 3 document statuses, unknown, valid, and invalid. So I have worked with distribution of data, so the database estimates it will get only around 93 rows with status unknown. So if I do this, it says that, OK, it will use index, all fine. However, a lot of times I see in the code things like that, so exclude. So the thing is, indexes do not work for negative expressions. It works for equality, greater than, less than. It doesn't work not equal. So if I see a query that is doing just the exclude and not a filter, it's a red flag, because database doesn't know that. So it can't use the index. It will go through the full table scan, although it will return exactly the same row set. So a quick fix for that is to calculate the kind of positive query inside the code. So I calculate for statuses which the query applies. So I get all possible values. I subtract the values I do not want to see, and then I filter kind of on a positive condition, and then it can use the index. So now let's create some indexes. So first, I had this case-insensitive query. So typically what people say, oh, well, I have an index on this name field. Why database isn't using it? Well, because database is looking for upper on the name. So it's not the same. So for us, it might be, oh, it's approximately the same, but it's not for the database. It wants to see exactly the same condition. So how to do that? So we saw that database is looking for upper on the name. So I have to create index which says upper on the name. Once I do this, database can use the index, and it's all fine. So now the query uses indexes. Now, closer to the problem we had, so what we were doing like live search queries. So as soon as you type like 3 characters, it starts to return results from the server. And how you do that in Django is you use this iContains. So it goes back inside the database, it executes as, so it looks for upper on the name and these two symbols, which in other databases they stand for like operators. So we have index on the name, we have index on the upper of the name, and it's still not using index. So what's the problem? The problem is that for this kind of like expression, database Postgres can't use this B3 index, so you have to create a different kind of index. So it's gen index. So way you do it in the Django, so there's a lot of boilerplate. You have to include this package inside your applications. Then you can create gen index with operator class on the upper of the name, and then some other boilerplate. So trust me, it's much easier to do that in SQL, but you have to, since you work with Django, then you have to follow this stuff. And then one more thing to make it work, you have to install this trigram extension, so you can do it once in your whatever migration file, and then it will work. So you can create the index. So I have created the index. I run the same query, but it doesn't work. Any ideas why? Well, the fix for this is to analyze the table, because database doesn't have statistics and it doesn't know yet about that index. So this is typical failure when you try to optimize create new indexes and the queries are not working faster, so it's often you have to analyze table after each creation of the index. And once I did this, so now it's great, so it uses our newly created index. Yeah, and it uses that for case-insensitive queries. Now, what if I want to do like case-sensitive queries? It can't use it. So the main point here is that it's looking for the exact type of index and for the exact condition that is there. So we do not have gen index on the name itself. We have gen index on the upper of the name. So now let's do JSON. So in Django, it's quite easy to work with JSON. So you just do 2 underscores and you can address the fields inside the JSON. So something like this, and I try to do the same case-insensitive search inside the JSON field. This is the query. So from all the previous examples, I know that I have to create gen index on upper and whatever this JSON field is. So this is how you create it. So this is by trial and error inside Django. So I had to add cast, because otherwise it would fail at the SQL execution stage. So Django itself didn't complain, but it complained later at the database. So this is how you create index on the JSON field. Now, the index is created, but still no improvements. Any ideas why? I did analyze the table. So this was a bit like brain teaser. So if you look at the index and at the condition that database is trying to execute, and you should pay attention to those 2 parts. So on the upper one, it says retrieve whatever JSON object is with this key. But when executing the database query, it's looking for specifically string type. So it returns only the string elements, named document type, not whatever integers named document type or JSON object named document, no. So how to fix this? So I gave up on Django, so this is how you do it in SQL. So for me, it's much, much easier and much more understandable. So I created the index, and we will go with, I know we are out of time, but we will go for 5 more minutes quickly. So we fixed the query, so now it's using the index. And now the exercise of putting it all together. So we are doing live search on something like 10 different fields on 4 tables. I managed to reproduce it on a 2-table and 2-field example. So we are filtering on the name and filtering on document number. So we just created the indexes for these specific kind of operations. And what we are doing, we are looking for members that match either the name or the member has a document with this specific string. So let's see how database will execute it. And so although we have indexes, it's not using indexes neither on the member, neither on the document table. So what's happening? Well, Postgres is being a bit stupid at this point. So I think the version 18 promised that there are some improvements for the scan4 queries. So I haven't tried it out yet, but hopefully it does. So I know that in Oracle, these kind of queries work like charms. So Postgres got me surprised here. So what you have to do for Postgres is to do actually more work. So you execute name filter separately, you execute document filter separately, and then gather the member IDs from both of these queries, and then run the query on those IDs. So this looks like really, really scary. But however, if you look at it, so it's executing much, much faster. So like 5 times faster. It's using index on the document number. It's using the index on the name. And yeah, there's possibilities for optimization, so you do not have to do joins. So we actually ended up doing something like this. And that's it. So one reason I wanted to give this talk is there's this research paper, so it focuses on not on Django, but on Ruby on Rails. And it looked what are the typical performance issues, and missing database indexes was the top issue of all web applications using database. To be fair, close second was the N+1 queries, but yeah, still missing database indexes win. And here's a cheat sheet for each specific kind of filter you write in Django. There's a specific index type. So sometimes people create a genop class on simple field and then try to use iContains and wonder why the index is not used. So it has to be matched exactly like this. And that's it. Thank you.
Thank you, Ivars, for this masterclass on database internals and indexes. So I recall that you can ask ask questions on pycon.it/slido. We have one question, and we have time for maybe one more. Can or should you run analyze table in a Django migration? And do you also manage your custom raw SQL indexes in Django migrations?
Yeah, so so another reason to do, like, first, I do create indexes, a lot of indexes with raw SQL. So the reason for that is because I want to use this concurrently feature so that it runs faster and it doesn't block the table. So therefore, there's the feature in Django where you can kind of write your own migrations, replacing the standard SQL. And then, yeah, regarding analyze, so no, I do not run it after each migration, but I know a lot of companies have the night jobs that just run it like during the night. So that's it.
Okay. Oh, we have 2 more questions. Let's see if we manage to do them quickly. What about index on the date time columns?
Yeah, so, well, B3 is fine. So because typically you look for the exact or the range. So that the one problem is if you are doing the query so Django allows you to cut, let's say, date and leave out the time part. So that will have problems. So it's better to do like full date time range, like convert your, let's say, year queries into like year, month, day, and some 00 as a time.
Okay, thank you. There's another one. Did you try to analyze queries in other databases like MySQL?
Sorry?
Did you try to analyze queries in other databases like MySQL?
Analyze, yes. Yeah.
Okay.
Yeah. So they have different names for same things, but the basic ideas are the same. So it's either the index or it's database. There are, so like, I don't know, index bitmap scans and index scans. So those are like different names for basically this. So if you do not want to go into like low-level details, it's basically the same. So.
Okay. Thank you, Ivars, again.
Mi sento osservato. Oddio, scusate.
Buonasera a tutti, benvenuti, buon pomeriggio. Ecco, a questo nuovo talk in cui ascolteremo Jacopo Spalletti che ci parlerà della sua esperienza dopo tanti anni con Django, no? Dove dicevo poco fa appunto che anche io mi rispecchio nella stessa esperienza negli stessi anni, no? È importante sicuramente ascoltare l'esperienza di chi ha lavorato su un framework potente come Django e che immagino tutti qua dentro utilizziamo, ecco, e di prendere i consigli che in qualche modo possono essere utili a migliorare le nostre applicazioni. Quindi benvenuto Jacopo, ecco, ti lascio subito la parola. Vi ricordo due informazioni. Un applauso, grazie.
Aspettate che finisca. Vabbè, dopo questa presentazione di Salvo, in effetti...
Un applauso spontaneo. Giusto 2 secondi per ricordare la sessione di QA con l'applicazione Slido, quindi se volete fare delle domande, e poi alle 5:15 il PyQuiz nella sala generale. Ok? A dopo.
Grazie Salvo per questa presentazione. Prima di cominciare voglio ringraziare gli aiutanti che mi hanno aiutato a preparare queste slide, perché mio figlio me li ha voluti dare perché mi facessero compagnia in questa avventura a Bologna, visto che lui non poteva esserci. Io ne ho viste di cose che voi umani non potreste immaginarvi. Server di produzione in fiamme al largo dei bastioni di Aruba. Ho visto lampi di CI balenare nel rosso delle GitHub Actions. E tutti quei momenti andranno perduti per sempre, come post-it in una retrospettiva. È tempo di debuggare. Noi sviluppatori siamo abituati... a vederne tutti i colori, quindi altro che i RGB alle porte di Tannhäuser, però è anche vero che molto spesso siamo noi stessi responsabili dei nostri errori, quindi imparare a farne meno sicuramente ci aiuta. Sono un vecchio brontolone perché uso Django da 15 anni, ma in realtà faccio questo lavoro ormai da quasi 30, e quindi ho fatto tutti gli errori possibili e oggi voglio condividere alcune delle lezioni che ho imparato e darvi spunti, però soltanto spunti per approfondire e adattare questi suggerimenti al vostro caso. Oltre al brontolone sono anche piuttosto conservatore, quindi l'approccio a nuove tecnologie, nuove metodologie procede sempre con grande cautela, diciamo così, tramite esperimenti e tramite prove. Ovviamente ci sono tanti problemi nell'implementazione che sono ricorrenti e sui quali come sviluppatori abbiamo comunque un controllo. Ovviamente i problemi più gravi che ci si trova ad affrontare sono codice confusionario, architetture fragili, che poi a cascata generano un sacco di problemi che rendono la manutenzione complessa, aumentano i costi di gestione dell'aggiunta di feature e rendono complessi i deploy in generale, tenere in piedi tutti quanti i nostri progetti. Non esistono però proiettili d'argento o soluzioni automatiche che possiamo applicare. Quindi quello che io posso fare è condividere cosa ha funzionato per me e per il team di Nefila e le soluzioni che nel tempo ci siamo costruiti, quindi questo in qualche modo è un po' un discorso corale, ecco, che viene fuori dalla nostra esperienza, non solo dalla mia. Non esistono soluzioni universali perché ogni persona ha caratteristiche proprie, con punti di forza e di debolezza e un qualunque processo di sviluppo in qualche modo deve tenerne conto. Ogni team è composto da una combinazione unica di persone e condizioni esterne che ne determinano il modo in cui lavora. Ieri il keynote di Semin Suleri ne ha spiegato benissimo, quindi non mi addentro ulteriormente. E infine ogni progetto ha vincoli e sfide diverse, per cui l'approccio che abbiamo usato con uno non funziona necessariamente in quello successivo. Ma quindi che cosa si può fare? La cosa che possiamo portarci dietro progetto dopo progetto, team dopo team, persona dopo persona, sono tutta una serie di pratiche di sviluppo che possiamo usare nel quotidiano e che ci possiamo appunto portare nel tempo e migliorare nel tempo. Stabilire pratiche e comportamenti comuni a tutto il team è in realtà il primo tassello per migliorare il proprio lavoro. E se io lavoro da solo? Beh, a meno che tu non sviluppi prototipi one-off, sei comunque in team con il te stesso del futuro, perché poi quel codice dovrai anche manutenerlo e quindi in qualche modo sei comunque un team. Sembra banale, le buone pratiche funzionano, soltanto che bisogna passare dalle buone intenzioni ovviamente alle buone pratiche in pratica. Ma quali ho trovato nella mia esperienza le più significative? Il mio giudizio, la prima da cui cominciare sono le code review, perché dalla massima resa iniziale e in un team sono uno strumento potentissimo di comunicazione interno che permette di condividere in modo efficace le informazioni, l'isolamento che una code review, l'isolamento del codice che porta a una code review fornisce un contesto che permette più facilmente di isolare i nuovi approcci e quindi di assimilarli, o anche soltanto vedere come un'altra persona del team ha risolto un particolare problema o ha portato una piccola innovazione, diciamo così, ci aiuta a analizzarlo, mentre commentare anche in modo molto pedante, magari a volte anche antipatico, il codice dei membri meno esperti del team, in realtà ho visto che gli aiuta a crescere molto più rapidamente di tanti altri approcci. Bisogna fare attenzione però perché le code review devono essere un momento di crescita e comunicazione aperta tra i membri del team, quindi devono arrivare al termine di un processo in cui si stabiliscono queste regole delle code review e soprattutto ci deve essere una comunicazione sempre rispettosa, non deve essere mai un momento di punizione o di rivalsa, siccome mi stai antipatico ti faccio tutti i commenti peggiori al codice. Tutto molto bello, ma se io sono da solo, che me ne faccio di una code review? Contrariamente a quanto dice quello, la risposta dentro di te non è sbagliata. Mi ricordo tanti anni fa, durante una 1-1 con un collega, mi disse che quando riceveva i commenti sulle code review da parte dei colleghi, i commenti che gli facevano gli risultavano ovvi e si dispiaceva perché in realtà poteva averci pensato in autonomia. Quindi parlando venne fuori che magari poteva provare ad aprirsi da se stesso una pull request, farsi una code review da solo e soltanto dopo parlarne con i colleghi. E nei fatti funzionò, perché poi all'appuntamento successivo aveva già notato, diciamo così, applicando questo semplice suggerimento, che diciamo così, aveva già avuto il suo effetto. E quindi la code review è il passaggio più immediato da fare perché non richiede nessuno strumento, non richiede una CI, non richiede un'interfaccia web, guardi i commit, insomma, richiede Git, ecco, in qualche modo. È l'unica cosa che richiede in fondo. Ed è abilitante per tutta una serie di pratiche successive. Ovviamente fare code review efficaci significa avere un modo unificato di strutturare il codice. Non serve niente di sofisticato, ma anche semplicemente introdurre strumenti come Black, Graph, senza grandi configurazioni perché fanno un ottimo lavoro out of the box, consente di limitare tutta una serie di litigi magari nel team rispetto a un certo stile di codice e con pre-commit si può forzare questa formattazione senza bisogno di CI o di altri strumenti. Nel momento in cui questo processo funziona, sicuramente bisogna andare a lavorare sulla documentazione, quindi vanno benissimo le docstring e il codice in linea, ma serve qualcosa di più, documentazione dell'architettura, schemi e diagrammi. Per questo motivo, praticamente in tutti i nostri progetti, abbiamo un progetto Sphinx integrato all'interno del repository, così da avere accesso, così che Sphinx abbia accesso al codice tramite Autodoc, creare documentazione automatica, ovviamente che va a analizzare il codice, ma anche uno spazio per documentazione narrativa, che di fatto poi è fondamentale per dare più contesto. Tutto questo poi permette di generare file statici e quindi pubblicarlo da qualche parte per poi avere accesso. Ovviamente il passaggio successivo sono i test, che sono un po' l'elefante nella stanza di tutti questi discorsi. Scrivere i test è soprattutto una questione di controllo del team sul progetto. Il team è in grado di decidere in autonomia se e quali test fare? Ovviamente non tutti i clienti, anzi quasi mai i clienti ti pagano esplicitamente per scrivere del codice, oppure magari uno ha un capo che non ne capisce il valore, fai presto che è tardi, oppure semplicemente l'inesperienza ci porta magari inizialmente a sottovalutare quello che è il valore del codice. La cosa importante da tenere a mente è che non bisogna essere perfetti nello scrivere i test, anche perché cominciare a dire ok, devo scrivere i test, quindi significa che devo avere il 100% di copertura, ovviamente è un ostacolo enorme, insormontabile. Ovviamente è bellissimo avere una suite del genere, però non sempre è possibile. Già avere qualcosa fa tantissimo per aumentare la robustezza complessiva. Noi stessi abbiamo da non moltissimo ereditato una codebase vecchia di 10 anni di 100.000 righe di codice di Python e faticosamente abbiamo adesso cominciato a costruire un primo tassello per poi andare a costruire dei test. È un processo lungo, non è così immediato. Ecco. Qualunque pratica però ha una componente ripetitiva perché deve essere qualcosa che fai giorno per giorno e ci vuole qualcosa in qualche modo che ti tenga in riga, perché sennò è facile poi abbandonarle quelle pratiche. Quindi tutta questa serie di controlli, se non li automatizzi, finiranno presto nel dimenticatoio. Quindi l'automazione deve diventare un mantra, una parte importante, anche se non così enfatica come il developers di Ballmer. Tuttavia bisogna anche non farsi prendere la mano, perché come Randall Monroe ci insegna, ci sono anche poi il guadagno diventa marginale o negativo rispetto all'automazione. Comunque, non so se si intravede, è la vignetta di XKCD sull'andamento dell'automazione. Non so perché, vabbè, simpatia di slide. Ma quindi, cosa si può automatizzare? Quali sono la scaletta di priorità, in qualche modo, di questa automazione? Il primo è il code style, perché è il più semplice, non richiede grande strumentazione. Si tratta, appunto, all'interno della CI, di eseguire sostanzialmente un comando che controlli la formattazione. I test sono il passaggio successivo, richiede sicuramente più infrastruttura, ma il valore di avere dei test che girano su ogni commit è ovviamente molto molto grosso. I controlli di sicurezza sono un altro passaggio che sia riguardo alle dipendenze sia riguardo all'analisi statica del codice possono darci benefici, anche se non sono sostitutivi di pratiche di programmazione sicura. E se la codebase è relativa a un progetto dockerizzato o un pacchetto Python o qualche altra cosa che richiedono build, ovviamente le build sono un elemento ovviamente da inserire all'interno. Alla fine il deployment che è sicuramente quello più complesso perché richiede tutta un'infrastruttura in grado di una gestione tramite automazione del deployment. Da continuous integration è ovviamente l'ambiente naturale dove far girare questi strumenti di automazione. Quanti di voi hanno già una pipeline di continuous integration? Ecco, abbastanza. E chi vorrebbe averla ma non ce l'ha ancora? Del resto esistono moltissime opzioni, ma voglio dire, da quelle hosted come le GitHub Actions a quelle self-hosted come GitLab, ma la loro adozione porta a costi e complessità non banali. Ma tutto questo non è strettamente necessario, ovviamente è importante, ogni strumento è importante, ma in realtà si può già fare qualcosa anche senza una continuous integration, perché esistono un sacco di strumenti per automatizzare in qualche modo il nostro flusso di lavoro. Il grado 0 è Bash, che ovviamente è un po' rozzo come strumento, però è assolutamente efficace nella sua semplicità. Just è un qualche cosa che va oltre, una specie di makefile, chiave moderna, per scrivere molto più semplicemente una serie di comandi locali. Fabric è grosso modo la stessa cosa, ma scrivendo codice Python, e poi Ansible e Terraform sono invece strumenti che lavorano a un livello lavorano sull'infrastruttura e ci permettono di automatizzare l'intera infrastruttura. Questa suite già ci consente comunque di lavorare e costruire comandi di grande espressività e complessità senza una continuous integration. Questo per dire un semplicissimo task in Fabric che in 9 righe ci permette comunque di scriptare, se non automatizzare, il deployment in progetto Django. Se uno non ha nulla è già un punto di partenza per non dover fare le operazioni manuali scritte in qualche wiki da qualche parte. Una volta fatto il deployment, siccome scriviamo codice perfetto, non avremo mai errori, è giusto? Se proprio abbiamo qualche scrupolo, ci possiamo affidare alle email via admin o login da qualche parte per tracciare gli errori. Ma in realtà, per fare un vero passaggio in avanti, bisogna lavorare sull'osservabilità, quella che si chiama osservabilità, quindi con strumenti che integrati nel nostro codice permettono di tracciare errori e performance e darci poi informazioni dettagliate. Sentry e Jaeger sono due dei più diffusi. Sentry è complesso da gestire in self-hosting e può essere costoso in versione SaaS, ma una suite di strumenti e di tracciamenti enorme in cui anche a volte è difficile diciamo così, districarsi, Jaeger ha uno scopo inferiore di manutenzione molto più semplice, ha il vantaggio che è basato su OpenTelemetry e quindi diciamo così, è aperto a tutta un'altra serie di integrazioni. Comunque sia, qualunque soluzione è migliore del login via email degli errori. Su questo tema comunque Riccardo Magliocchetti parlerà domani, quindi sicuramente lui approfondirà meglio di me questo punto. Indipendentemente dal punto di partenza, sulle pratiche la cosa fondamentale è iterare, migliorare la capacità e migliorare la capacità di usare questi strumenti. Fino adesso abbiamo girato intorno al codice, ma ora è bene parlarne un po' più direttamente. Oltre alle pratiche che seguiamo per scrivere il codice, ovviamente l'altro elemento fondamentale è sapere come organizzarlo. E in questo ci sono ovviamente design pattern, architectural pattern che ci aiutano a districarci nelle varie possibilità. E qui potrei fare un pippone e parlare per ore e ore e ore, cosa che non farò. Sicuramente è importante avere tutta una serie di nozioni di teoria, e qui ce ne sono alcune sigle che a volte vengono usate in modo molto, diciamo così, con schieramenti molto netti. Personalmente, come dicevo prima, sono molto pragmatico e cerco di filtrarle sempre attraverso il pragmatismo e soprattutto sulla base della filosofia di base di Django, perché di quello stiamo parlando. All'inizio per progetti semplici o con poca esperienza, se uno ha poca esperienza o uno sta lavorando su progetti semplici, lavorare con le generic views va benissimo, non c'è bisogno di fare service layer o cose più complesse. In queste prime fasi la logica può essere aggiunta sui model e l'importante è tenere view assolutamente scarne, mentre invece lavorare sui query set aggiungendo lì i nostri filtri ci aiuta tantissimo. Ora vedremo una serie di esempi di codice che sono molto, diciamo così, sono molto di presentazione, non sono pensati per girare così come sono. Personalmente trovo queste 5 righe di codice che già ci forniscono la possibilità di fare l'edit di questo model elegantissime e difficilmente battibili se uno non ha grandi necessità. Per di più si possono estendere con logiche di validazione tramite l'inserimento dei form in modo molto naturale e comunque avendo della logica esattamente dove deve stare, ecco, nell'ambito dell'architettura di Django. Logiche più complesse invece possono essere più complesse da andare a integrare. A parte la semplicità e la stupidità della logica, ma avere un metodo sul model e richiamarlo dal save del form ci permette di separare molto più nettamente le cose e quando la logica non è particolarmente complessa è comunque un approccio decisamente vincente. L'importante è lasciare davvero al minimo le view, ora magari non così minime perché sicuramente avremo bisogno di controlli permessi, un minimo di filtro degli oggetti, gestione render del template, dei form, ma ecco, non andrei ad aggiungere altro e le terrei davvero al minimo. Come dicevo prima, un altro elemento importante è lavorare sui query set perché con una riga li puoi aggiungere direttamente sul model ed estenderli e quindi strutturare e concentrare il codice di filtro. Tutte queste possono sembrare cose ovvie, ma in realtà nella mia esperienza, diciamo così, cioè se uno ha un po' di esperienza possono sembrare ovvie, ma in realtà poi è capitato spesso di doverci ritornare sopra. Anche questo non si sa per quale motivo non si vede. Volevo parlarvi in realtà di Django Filter e Django Model Utils, che sono due pacchetti che trovo assolutamente insostituibili per lavorare su questi, per migliorare la qualità del nostro codice idiomatico di Django e quindi ve li consiglio assolutamente, poi nelle slide ci saranno tutti i link anche se qui non si vedono. Però l'approccio Fat Model arriva fino a un certo punto. Quando abbiamo bisogno di scalare abbiamo bisogno di qualcosa di un po' più complesso. A seconda della metodologia possono chiamarsi service layer, use case o 1000 altri modi, ciascuna metodologia poi li declina nella sua modalità, ma l'idea è avere delle scatole, diciamo così, delle black box che implementano delle logiche e riusarle indipendentemente dal flusso. In base al pragmatismo che ci siamo dati, noi prendiamo queste cose, varie idee da varie metodologie e li facciamo nostre lì. li portiamo, diciamo così, nella nostra modalità. Questo è un esempio semplicissimo, diciamo così, banale quasi, di service che gestisce un trasferimento fondi, potrebbe fare qualunque cosa. L'importante è che una volta scritta e testata la possiamo riusare ovunque, perché non è legata a nulla se non ai propri parametri, non ha nessun legame con il contesto in cui viene eseguita. La cosa importante da sapere è che, anche se Django, qui non so, scusatemi, quello che voglio dire qui è che siamo molto apportati a pensare in termini di ereditarietà quando si lavora ovviamente sulla programmazione oggetti, ma in realtà sulla business logic bisogna fare molto affidamento sulla composizione, quindi creare elementi abbastanza piccoli da poter comporre nel nostro codice. Io trovo in Django, in generale in Python, più comodo avere degli oggetti stateful, perché sono molto più naturali e ci permettono una serie di passaggi ulteriori. Ovviamente poi a volte le service class sono semplicemente delle funzioni, ma questo ovviamente non ci sorprende, insomma. Esempi più complessi ovviamente rendono necessaria una vera e propria classe. Ma come fare in Django? Qui vedremo delle cose un po' strane, perché il normale flusso di una esecuzione di Django prevede, ora qui probabilmente non si vede, no, il puntatore non funziona, comunque abbiamo view, form e model e poi eventualmente da qualche parte la logica, che però non ha un posto in Django. Quindi succede che noi abbiamo tutte queste frecce che vanno avanti e indietro, apparentemente da view, form e model, verso questa logica che non si sa bene che cosa sia, mentre invece se introduciamo il nostro strato di service all'interno tra form e model abbiamo un diagramma di sequenza molto più ordinato. Ma come possiamo fare? Quali sono le opzioni che abbiamo? Ecco, va bene, andiamo veloce. Per esempio nel form, prima era la view ma tanto quella era la cosa più inutile, nel form potremmo inserire una cosa del genere, però comunque è scomoda da usare rispetto, anche se meno scomoda rispetto alla view, ma comunque è una struttura piuttosto scomoda. Mentre invece noi possiamo pensare di prendere il nostro service e integrarlo, scusate, va bene, facciamo così, e integrarlo all'interno del nostro, va bene, si rifiuta di lavorare, va bene, scusate, proprio una cosa al volo. Non questo, ok, vediamo se si vede meglio, no, non si vede meglio, non importa, ve lo spiego a voce. Quello che voglio dire è che noi possiamo sostanzialmente, no, neanche questo si vede, ma noi sostanzialmente possiamo nel form, poi nelle slide che pubblicherò si vedrà, ma comunque all'interno del form noi possiamo esporre la logica di validazione della service class e fare l'override del save del form per eseguire la service class e riportare gli errori esattamente come se fossero errori del form e poi all'interno della view andare a esporli in modo, diciamo così, come se fossero errori del form. Vale la pena di questo approccio che smonta un po' tutta quanta la logica di Django? In realtà dipende, ovviamente, ha dei vantaggi perché sicuramente permette un maggiore riuso del codice, permette di migliorare la qualità dei test perché comunque è tutta logica sganciata dal resto, dal funzionamento delle view, permette di isolare il codice all'interno di funzioni che sono libere dal flusso, ovviamente a prezzo di complessità e di codice non idiomatico. Volevo parlarvi di comunicazione asincrona, ma abbiamo pochissimo tempo, però cerchiamo di farcela e soprattutto di avere delle slide che collaborano. In tantissimi ambiti capita di dover disaccoppiare, diciamo così, qualcosa che produce un qualche tipo di messaggio e qualcosa che lo consuma. In questo caso un'implementazione tramite PubSub ci può rendere comoda la cosa, va bene. Scusate, ma così è un po' difficile farvi capire le cose. Il proiettore ha deciso di non collaborare. Ecco, ma è lento il... Se così ci aiuta, perché se no davvero fate molta difficoltà a seguire quello che dico. Ecco, ora sembrerebbe essersi ripreso. Perfetto. Quindi, nel nostro caso, per esempio, vogliamo prendere un messaggio che ci arriva da una sola fonte e distribuirlo tra più applicazioni. In questo caso possiamo, ad esempio, esporre un endpoint tramite FastAPI, collegarsi a Redis e poi a runtime, quando ci arriva il payload con il messaggio, pubblicarlo sul canale Redis. In Django però abbiamo il problema che il subscriber deve essere sempre collegato e Django invece lavora su una base di request response. Però abbiamo alcune soluzioni che ci permettono di integrare questo processo in Django. Per esempio con Channels, se abbiamo bisogno di comunicare con dei client, quindi mandargli delle notifiche, per esempio, possiamo usare un approccio basato su Channels, per cui quando il client si collega via WebSocket, noi creiamo la nostra comunicazione a Redis e poi qui rimaniamo in attesa dei messaggi in una connessione persistente WebSocket. Se invece non abbiamo bisogno di una comunicazione con il client, possiamo basarci su Celery, ma Django Queue o task, o i background task di Django funzionano allo stesso modo, per cui all'avvio di Celery il task viene creato, quando si avvia crea una connessione verso Redis e rimane in attesa. La cosa importante, perché fino adesso sostanzialmente abbiamo implementato un pattern observer, l'importante in questi casi è usare un pattern strategy, quindi un message handler che in base ai tipi di messaggio poi demandi tutto alle service class, e ci ricolleghiamo al discorso di prima. Incapsulare tutta la logica all'interno di elementi autocontenuti e autonomi in realtà ci permette di estendere molto più facilmente questo tipo di approccio. Un approccio del genere basato su PubSub o altri meccanismi che non basati su Redis, ma usato Redis per semplicità, ci permettono di disconnettere completamente publisher e subscriber, usare tecnologie diverse, basta che abbiano in comune e possano collegarsi in questo caso a Redis, e in realtà ci permette di supportare tanti meccanismi, tanti use case diversi, dagli webhook all'IoT, in cui abbiamo usato questo approccio su altri progetti e altre cose che possono venire in mente. Grazie a tutti, spero sia stato interessante, mi spiace per le slide saltate, ma le ritroverete poi.
Un minuto preciso per, appunto, anzi 2 minuti precisi per due domande.
Perfetto.
Sono arrivate, anzi ora ne è arrivata un'altra. Django FastAPI, cosa preferisci?
Dipende, sono cose diverse. Io nasco con Django, ovviamente FastAPI è molto recente, dipende da quello che devi fare. Se devi fare un monolite, lo fai con Django, e i monoliti hanno assolutamente il loro ruolo nelle applicazioni web. Se hai bisogno di un web service o di un microservizio abbastanza limitato, FastAPI è oggettivamente comodissimo.
Per l'observability hai provato Prometheus più Grafana?
Scusa?
Per l'osservabilità, observability.
Sì.
Hai provato Prometheus più Grafana?
Li conosco meno, non li ho usati più per magari monitoraggio dell'infrastruttura piuttosto che delle applicazioni, quindi li conosco meno, ma sono assolutamente alternative altrettanto valide.
E invece con Django quale consigli dai per implementare unit testing?
Ma io ultimamente, da un po' di tempo, uso PyTest e lo trovo comunque molto buono, più che altro perché il meccanismo delle fixture è francamente un meccanismo molto flessibile che i test case standard di Django faticano a replicare in termini proprio di componibilità dei nostri test e riusabilità. Alla fine il setup o il setup class dei test case di Django tendono a essere pesanti anche, e a usarli anche quando non servono, insomma, cioè vengono eseguiti anche dei test in cui non servono, quindi non sono il massimo.
Ottimo, grazie Jacopo.
Grazie a voi. Maledette slide.